30, not counting advent of code streams. Let's see how good of a chance I have to get the transcoder. Oh, I got it. First try. I think it's the time of day. When I start in the early afternoon or in the morning, for me, I usually get a transcoder. It's when I start in the evening, it's been tough. Yes, hello. This is stream number 430. I'm working some more on Raft Consensus, the Raft version, or the Rust version, and I'm going to confuse these two words a lot. Raft, Rust. They're both four-letter words. They both begin with an R and end with a T. They both have a vowel in the second character. It's madness. Anyway, I finished the election stuff, and I refactored this quite a bit. So it should be easier to read this code now, especially if I collapse it and we look at the mobilization implementation. I'm not too happy with that name, but it's the closest name I've come up with. So this is the part of the server that operates when the server's mobilized. So it contains, where is it? This one. It contains most of the working variables. So the one shot we use to cancel the election timer, the cluster configuration, the current election state. For testing, we keep a count of the number of times we've had election timeouts happen. We remember the server's ID, the last index and term of the log. Actually, maybe we don't need these because the log has that now. The log has the last index and term. So I might not actually need that. Anyway, we have state for every peer, so the other servers. The other servers, for those we track one shot for when we need to cancel a retransmission timer. We have, when we set up a future to handle retransmission, we store it there until it gets collected. And then we remember the last message we sent, the sequence number of that message, and then we remember whether or not that we received a vote from that peer if we're a candidate. And then we have two dependencies injected into this. We have the log and the persistent storage. We also use a random number generator. This is used to compute the election timeout intervals because the algorithm specifies they need to be chosen at least pseudo-randomly, if not randomly. Okay. So these two dependencies, log and persistent storage, they kind of mirror what the Raft white paper talks about, that there are certain variables that need to be durable. And right now we have term, which means, how to put this into the right words? It's an arbitrary number that increments every time that there is a new election in the cluster. So whenever there's the old leader is no longer capable of maintaining the cluster, an election gets started and this number gets incremented. So we use that to know when to stop listening to one leader and start listening to a different one. We need to remember who we voted for if we voted. So those are right now the two most important durable simple variables. Everything else is stored within this log dependency. That log dependency is supposed to be able to accept log entries. And for convenience, I made one that has it accepts one entry, another one that accepts a bunch that are in an iterator. And then the log is based off of a state snapshot. So the last term and index that went into creating the snapshot, we have to be able to recall. And then there's going to be more methods, but right now, all we need to do after we put entries into the log is we might later come back and say, well, what was the term and index of that last entry? The term of an entry is going to be the term of the leader that made that entry. The index is just another number that increments every time we append something, so it's just constantly counting up. The algorithm depends on both the term and the index numbers to achieve consensus. So not to go into more details, but if you happen to be here lurking and you want to know more about Raft, there's a link for you. All right, so it's been a while since I've gone like 5 minutes without anybody talking in chat, but you know, it might be one of those days. It might be because I haven't streamed in a week, except for admin of code stuff. All right, anyway, we have functions for when a server becomes a candidate, follower, and leader. We can cancel the election timer. We can cancel retransmission timers. We can change our election state. We can decide whether to honor a request or not. We can decide to grant a vote or not. We can handle an election timeout. We can make a new server, mobilization. Oh, Necronos. Hello, you're the first. Welcome. I'm working on Raft today in Rust. I'm just reviewing the work I have done in the last couple of weeks. So I have a function for processing every kind of received message or received item. So we could be receiving an append entries results. So these exactly mirror what's in the white paper in the algorithm, right? The different kinds of messages we might exchange with other Raft servers. Process sync items is when the host of the server locally presents some work. And right now the only work item is that you've received a message, and this is going to call process receive message, and this has a big match to see, well, what kind of message is it? Is it a request vote results? Is it a request vote? Is it append entries? Or is it append entries results? Those are the only messages right now that we handle. There's going to be a couple more that I add later when we do snapshotting. If it sounds like I know what I'm doing and what I'm going to be doing, it's because I already did this in C++ a couple of years ago. I'm kind of like redoing it now in Rust. The C++ implementation was poor enough that I don't really want to port it as is. I'm kind of just leveraging the experience and knowledge from doing that and kind of doing it again this time in Rust, and maybe hopefully better. So I have marked down here things that are not yet done, and because we're passing all of our unit tests, that means I need to make more unit tests to catch these things that aren't actually being done yet. Let me make sure that the unit tests actually run. So we'll go to Raft, and not Raft, and not Caft, but cargo test. It's going to spit out a lot of standard output because we have a lot of print statements in there. But at the end, yeah, we see that, if I expand this a little bit, we should see that. Come on, computer. I can't get, there we go. 43 tests all passing, no documentation tests. All right. So that's my intro, which lasted 7 minutes, 35 seconds. Now into the actual work. So I can just pick one of these, what I feel like making a unit test to track. Blind first match, don't blindly append entry. To test this, we need to have some pre-existing things in the log, right? And have it only append the new ones. I think that's what we did. Hey there, Romania. Hey, you're the second one here. It's going okay. I didn't feel as motivated to stream again today. Maybe because it's Monday. I have been doing a lot of work on this code behind the scenes, so it should be a lot cleaner than it was last week. You feel me? Is it just Monday? Is it just a Monday? I also split up my unit tests into different categories. So if we know we're working on replication and we know we're handling a response, which we are, right? No, we're handling an entry, so it would be a request, right? That we should be working in this file, I think. Oh, no, I have it backwards. Replication request handles when the server sends out requests. Response is when it receives a request. So what was this again here? This is when it receives. So this would be response then, when we need to generate a proper response. Just finish some work-related stuff. Feels like having a code task. Yeah, it's like, do I really want to work on Advent code when it's the same kind of work as my job? Wasn't a Buff Seagull having trouble with Advent code because it was it day 4? He said it was pretty much the same as his job, and so he didn't want to do it. Okay, so I want to make a name that has to do with this item. So something like follower match correct entries. Well, match appended entries, right? Hey there, Metro Dev. Hello. Okay, so we make a test fixture, we make 2 mock dependencies, we make a server, mobilize it with those dependencies, And we don't want to do this election, do we? Yeah, so that goes. We want it to remain a follower. Okay, I need to do a little bit more though, because I want there to be like already something in the log, and then have a server send us an append entries that contains some of those entries that we already have, plus some new ones. Working from home is great. Sometimes get to catch our image stream on the side while working. Excellent. So when we make a new log, this doesn't give us the opportunity to start it off with any entries, right? Actually, I guess we could fill it with entries because these are all public, right? So I could do this, right? I can, after making a new one, I can just go and directly add stuff to it. I can do append. There we go. Do I need more than one? I could just handle one, right? There doesn't need to be more than one. So just append one, maybe? Just keep it simple. So this will be log entry of some kind. That log entry has a term and a command, right? So term, let's say term is 1, command is none. Because we can, right? We can have an empty command. This needs to be marked mutable for us to do that, though. So this should... I wish I would control-click and go to the mock log. This should add one to the last index, update the last term, and then push the entry into the list. Right? So then we would mobilize a server. So it starts off with a pre-existing log entry, right? Then we would send the server an append entries that contains two, and I want to make this 2 entries now. One that matches the previous one and one new one, like that. So since we have a new one, I need to make it different, right? And then previous log index should be 0, basically saying that this is index 1, that's index 2, right? And then the term should match at least the term in the last entry. This is just an arbitrary sequence number, and this is the ID of the server that it came from. Yeah, so we should expect a response of it did not change state, it's still a follower. Match index should be 2, because it should match this one and append only that one, right? Term should be 0, because that's the term it was in before. And then there should be no state changes. Well, I guess that goes without saying, right? Other tests check that. Right, we want to verify the log. This should be updated to say it's term 2, and we didn't vote for anybody, so that should be a none. Right, so we should have the one we had before plus the new one, right? A term 1 command and a term 2 command, none. So there we go, there's my test. TDD, yes. That's the whole point. I've been trying to do that for years now. I wouldn't say I'm an expert, but I try to follow that. Right, so that the test fails. We have a match index of 3. That's actually not very good. I expected that to not advance at all. Why would it be 3? Oh, I know why. Because it added both. So that's the bug. It should have matched that it already had this one. Right, okay. So now I understand why it's broken, because we didn't write the code to say that we already have that entry, so don't add it again. So it'll end up adding both of those and saying, okay, now we have 3 entries. This one twice and then this one, which is wrong. You already handled the election time electric? Yes, I did. I did that off stream. Struggling to figure out how to best do that in your Raft mess? I can go over it to show you what I did. Let's go over that. So it all has to do with election timer and then what to do when you are asked to vote and you get a vote. Hey there, Lazy Guru. How are you today? There you are over there. I'm like looking around wildly. Where should I look? I still need to get into the habit of looking at the camera. A lot of the times I just look over at chat and you're not over there. You're up there. Okay, anyway, so crucial aspects about the election system in Raft is election timer, and then sending out vote requests, deciding what to vote for and who, deciding who to vote for, and then receiving votes and interpreting them. So let's go in order. The way I do election timers is where in inner, no, it's in the outermost server, right? Oh, no, I refactored this. Okay, so from the outermost, gosh, how do I explain this so that I don't have to explain everything? I'll just say when you create a new server, it makes a scheduler, which could be mocked. So with the test configuration, we actually make a mock scheduler, and otherwise we make a non-mocked scheduler, and we'll call new a scheduler. And this creates a channel for sending in commands and a channel for receiving back out events. So it's commands in, events out. And with those sender and receiver, we store one side, and we put the other side into a worker thread. Where did command receiver go? Command receiver goes there. Where does event sender go? Event sender goes into the inner. So right, inner is going to be the state of the server's worker thread. So we're going to go in there. Okay. And then it's basically looping on many different things that might happen. So one of the things that might happen is the election timeout. We have to actually set it up, though, if it's not set up. So, and we only want to set it up when we're mobilized, because the order of events, I should have said, after we create a new one, the worker thread starts, but it doesn't really do anything until we tell the server we want to mobilize. The reason why I broke it up into a two-step process like that is I want to be able to like tweak the configuration by calling configure. Configuration has like what are the timeout interval ranges, or the range for the election timeout. So you might want to tweak that, and then mobilize basically says, okay, now go set up your timers and everything. So that's here. But anyway, all gets handled by this worker thread. And if we are mobilized, then we're going to, every time we loop through, we're going to decide, do we need to set up an election timer? And the logic for that is, if we're the leader, or we already have an election timer, we know we have an election timer if we're holding onto the cancel channel, the channel that we'd use to cancel the timer if we don't need it anymore. If either of these is true, we don't need to do anything. Otherwise, we determine a timeout duration by generating a random number between the start and end of that timeout range. And then I have this way to make a future which completes if it's either canceled or the time elapses. And then we put that future into the inner and return back out. And then what happens is, how does that work? Oh, no, we store the cancel channel in the inner, and we return the future. That future then gets pushed into this vector of futures. That vector of futures is what we're going to block on, essentially, right here. So if the election timer were to happen, it would come out as a work item election timeout, and we would then trigger the election. So with the election timeout, we basically remove and drop the cancel channel. We add, if we're test configuration, we add one to the timeout counter that we use in the unit test to make sure we have the correct number of election timeouts. And then if we're not the leader, we become the candidate. Becoming the candidate means we increment the current term by 1. We change our state to candidate, and we send out a new broadcast message, which is to request a vote in our, where's the term written? Oh, this must grab the current term. Yeah, we say the candidate is ourselves. We advertise our last log index and term, so the algorithm requires that. And then these are the objects that are needed to send out events. Using a channel to basically do notification that occurred? Yeah. And I'm good, Lazy Guru. Thanks for asking. I hope you're well too. So yeah, when we get down to send new message, this grabs the current term, and then for every peer we're configured to talk to, we send that peer a message. And the way we send a message is we construct the message value. We are tracking the sequence number so that we can match responses with requests, right? Because it's oh, thank you for the follows. I appreciate it. It's a what's the right word? The RPC mechanism we're assuming is one that you could have dropped messages. So the sequence number is what we use to see if we get an answer for that one. If we don't, then we just retransmit the message. But anyway, send a request, clones the message so we can store it in last message, and that's important for retransmissions. If the retransmit timer fires, then we're going to take that last message and try to send it again. So this, just like the election timeout, we make another timer, but this one it's based on the RPC timeout, which is a much shorter interval. And if that times out, then we'll have a retransmit work item. And yeah, the way we send is we send it through this MPSC, this multi-producer single consumer channel. And so going back up to the very top, if you remember where I created the channels here, I took that receiver and stored it in the server, because the way I decided to make it used is through the futures extension sync and stream. So for a stream, the item is an event. So how the end user would use this is they would iterate over the server stream, and every event is either send a message or to notify them that the election state changed, and there'll be more things that the server might want to tell you about. So when the server tells you send message, you're supposed to then transmit that message. Okay, and the other direction is sync. So if you need to tell the server that something happened, like a message got received for it, you would send into the sync of the server, and then that goes through the command sender, and then that drills down into where we actually use the command receiver, which is right here. Every loop, we make sure that if we have a command receiver, that means we need to put it into a future to process the next thing that might happen. So that's what this is doing. We take it out, we give it to a process command receiver, which is a future, asynchronous. When it completes, it's going to end up giving us a work item, which is either there's another command or it got closed. If it's a command, then the command receiver comes back out with the next command. I'm using the magic of into future. So what that does is it takes a MPSC channel and waits for the next item to come out of it. And when that happens, it gives you that item along with the channel again. So this is suitable for looping or iterating. So every time you call it, you're going to get the next item, unless the receiver, the sender is closed. In that case, the receiver will return none, and then we mark that as a special work item called stop. Those futures channel those are futures channel MPSC. Yeah, this is all asynchronous. So this is an MPSC unbounded receiver of commands. You ever heard the Stormtrooper band? Probably not. They've never had a hit. You're reminding me of the last Mandalorian episode, but I can't say anymore because it would be a spoiler, Mr. Balrog. This is extremely helpful. I'm glad it was, MetroDev. So anyway, let me complete this. You might not need to know the rest of it, but I kind of feel like completing it. When a command comes back in, right? That comes out as work item command. Right here. So we do process command, and amongst the things that we could have told the server to do, we could have told it to change the configuration, to demobilize, to mobilize. For testing, we can fetch the election timeout counter, and here's the most important one, is the sync item, right? So process sync item says it'll only do something with it if we've mobilized. That's what this check is for. If we mobilize it, forwards it to the mobilization, which says, well, what is the sync item? If it's a received message, then we tell the mobilization to process that received message. So if the received message, and here's where it breaks down what are the things that a Raft server might receive. It might receive a vote, it might receive a vote result, append entries, or append entries result, and there are a few others we're going to add later. So at the top level, it's sync and stream to go in and out of the object. And then between that and the worker thread, we're using MPSC unbounded channels, which are really convenient because you can turn them into futures, which is what I was doing when I do into future. Where was that? Let's just search for into the future. Right here. This thing is a MPSC unbounded receiver, and you can turn it into a future that completes when you, this is a feature that when it completes, it gives you the channel back out plus the item that was received on it. Why unbounded? Because if you bound it, then you have to worry about it failing because the worker thread is too slow, or in the other direction that the user doesn't consume the events generated by the server. So it's a trade-off between, do you want it to consume lots of memory or not? Unbounded could consume a lot of memory if the receiver is slower than the sender. It's not truly unbounded. It's bounded by the amount of memory you're able to allocate. But a bounded channel is arguably faster and more efficient because you're not having to allocate memory. But the drawback is that if the receiver can't keep up with the sender, the sender might not be able to send anymore. It'll get either blocked or it'll have to drop things. So unbounded sender is the simplest because you rely on the channel to basically stretch and allocate more memory as needed. And so the send only fails if the receiver was dropped, and the receive only fails if the sender is closed. I think. Yeah. That's why we have this, if we get a none, then the sender must have closed, so we would say stop. And that stop is actually crucial for the shutdown process, so, where is that? Where this is handled. Yeah, right here. That's the only way we break out of that loop that the worker thread does. There's no other way to actually stop serving other than for the command sender to be closed, which we detect as a none coming out of the receiver, which we translate to a work item stop, which we translate into a break. And then we close the circle in the drop for server, because what that does, way down here, when we drop the server, we tell the command center to close, and then we take the thread join handle and call join on it, which will block until the command receiver has received that none and output it. That goes with the close. And then the break happens, and then the serve function returns, which completes its future, which terminates the worker thread, which allows us to join it. So we go full circle there. Doing a custom drop, that's right. I think it's appropriate to do a custom drop to join your worker thread when your new spawns a thread. So this is just my approach to managing a worker thread that's tightly bound to a value, is created in new, join it in drop. And always with that pattern, right before you join, you need to do something that will trigger that worker thread to exit. Otherwise, this join will deadlock, right? So I happen to know that this guarantees that we will get a stop because we detect that it's been closed by getting a none on the receiver there. I think you're reading something similar approach to multi-threading. So I don't know if it's clever or not. It's just what I'm used to doing, even from C++ days. What I've heard other people doing is, instead of having a dedicated worker thread, we could take this serve, which is technically just a future, and we could just return that and then let the user deal with that future, right? Say, hey, this future runs the server, so, schedule it on some executor and have fun. And then we would then change the drop, I think, to just close the channel, right? Or something. Actually, we might not even have a drop, right? Because if we just return this serve future, then maybe all the state maybe this server object doesn't even need to exist, right? Because it wouldn't have a join handle. These two are only hold on to through, actually no, we still need that because that's needed by the sync and stream. Yes. So I think what we would do is, if we didn't spawn a thread to run to block on the executor that future. If we just return the future alone, we would only need to close the channel, and then we would say, well, now that future will eventually complete somewhere else. We don't care anymore about it because you dropped it, which means you're not needing to handle the stream or the sync anymore. So it would simplify it, and I wouldn't need the custom drop, and then you'd be more free to say where that future runs, I guess. It might not be on a thread at all. It might be on a more complicated executor. Anyway, musings of what we could do. I worry about this maybe being too constraining to a user. This basically says, if you use my Raft implementation, you will have another thread, because we spawned it ourselves, and that thread is going to run the entire server. And so none of the work of the server can run anywhere else but this thread that we spawned. So it's a little bit constraining. If we relax this and maybe return this future, and we said, hey, put it on a thread, give it to an executor, just do something, put it somewhere, then that would be a little bit more flexible, I think. Hey there, Arctic Space Fox. How are you today? Watched Toggle Bit yesterday? I did last night, yeah. Weren't you there too? I only watched enough. Well, not enough's the wrong word. I only watched until I had to go to bed. Same day for you? Time is a weird thing when the Earth is rounded, isn't it? For me, it's a different day. Today, it's Monday. I have to remember when I watch Toggle Bit, I have to say happy and then insert a day, which is the current day plus 1. So on Sunday night, I have to say happy Monday. And it's his Monday morning. I guess I'm assuming you're on the same part of the Earth as him, or in that slice of the Earth. So for you, it would be a Monday night, correct? Yeah. Small world. Digitally. Okay, I was sort of giving a tour of my Raft implementation. The work I'm doing right now is test-driven development based off of this test, which is failing right now, which is that a follower should match appended entries, and right now it doesn't. It always adds them. So we ended up with 3 when we should have gotten 2. We start off with 1. The server repeats that 1 and gives a second, and so we should get just the new one and keep the old one. But right now, in reality, we're getting 3. That one twice, and then that one. Sadly, not in the Arctic currently. You're in Germany. Yeah, well, that's the slice of the world which has the common time that Togglebit is in, right? Thank you for the florp spam. All right. To make this test work, we need to do something more complicated when we're handling this append entries command. So we handle append entries. Let's find it. It would be in process append entries. There we go. And so it matches this first to do. That was the whole point. We don't want to just blindly append an entry. We want to find where they first match. Basically match what we have with what we just received. And we would do it after we become a follower. So it's this blind append we need to fix, right? So I'm thinking what we'll do is we'll just walk from the oldest received one up. And right now we'll not assume that we're receiving one that's like out of range or anything. It's just to get the test to pass. No, we're done with voting. We're doing replication of state now. This appending log entries. So all the election stuff's done. The election is complete. I laugh because it sort of is a pun on the state of American politics, right? Is the election complete? We don't know. Don't I just want to loop here? Fundamentally, I do want to iterate that. But I need to find where to match it up with the starting point, don't I? I can have another variable that tracks the index, I suppose. That's what I should do, because they gave us the index here. Right, so this is the base term and index upon which this log is built. So that's what we should do. We should say let index equal append entries dot previous log index. And this should be mutable because we're gonna be advancing this as we iterate through this, right? So then I can just do this. I can say append entries dot log dot, well, for entry in log entry in that. So this should be the correct type, right? Log entry. Right, great. So we would need to make sure that if we have something based on this index, that it matches, right? So then, do I delegate it completely to the log? If so, I would say something like if self.log.index. Let's say we can index. We would index index. And we would say if its previous term matches, right? Well, if let some, let's call this one new log entry, and we'll call this one previous log entry. Then maybe call this one previous index. Equals that. What's this? A list of states? Did you know that you can theoretically win the vote with 21.9% of the votes? Oh, because of the difference between electoral college and popular vote? Yeah, it's pretty crazy. Basically, you need to win all the states that have the highest ratio of electoral college voters versus actual voters. So you just listed all of the largely rural states, right, that have the fewest people but have the disproportionately high electoral college votes. Yep. Yeah, kind of weird how our American system works. Okay, for new log entry in that, if we have someone, then we need to see if it matches, right? If we don't have one, then I think we could just safely append it. But only if the log matches, right? We should say like else if previous log index equals self.log.last index. Otherwise, it's based off of an entry we don't have, which means we'd probably just want to break, right? Hey there, Alt-F4Stream. You wanted to say you saw this coming? Interesting to see me implement Raft and Rust. Yeah, you knew this was coming, Alt-F4Stream. And how are you doing? Say hi to Mr. Balrog, and hi to Arctic Space Fox, and to Alt-F4Stream. Hello. And hey there, Simon Filippi. What am I coding? I'm coding Raft. It's a consensus algorithm. Actually, let's get that link out here because when inevitably we want to talk about the algorithm from a high-level perspective, I'll have that ready to go. Let me dark reader it so it doesn't blind people. So you can read more about it at that link. But essentially what's going on here... Oh, that's why I don't use dark reader with this, because it messes with the colors. Okay, but you can see that there are 5 circles. And they just had a flurry of activity there. S3, which now pops up in red so we can actually see it, became the leader. And what the algorithm allows you to do is have, if I say request a few times, we're having the leader create state changes in its local state. What the algorithm allows you to do is replicate that state to other nodes. Could be other programs in the same machine, or there could be different nodes in a network. In my case, there are different copies of my game, because my game sits on this kind of framework. So you'd have 5 copies of whatever it is you want to replicate. Essentially, you'd have the original state plus 4 backups. The algorithm guarantees that, let's say we stop that server, that the you'll lose sync momentarily, but one of these servers will say, hey, we haven't heard from the leader in a while. How about I become leader now? That's about to happen here. In fact, these two both timed out, but this one will end up winning because he got the most votes. So now he's the leader, and he can advance the state. Even though the original server S3 is still down, we can still advance the state of the cluster. Eventually S3 resumes, and it will catch up. So S3 will start replicating the state of the rest of the cluster. So that's essentially what the algorithm lets you do. Have copies of all your data so that the hosts can crash or be stopped, and yet the overall progress of the state changes can continue as long as you have the majority of nodes still running. So one thing I use that for is I would like to update my game periodically with new code. So what I'll do is I'll stop each of these servers in turn and update them. While it's stopped, the game can still progress because the other servers are still running, right? So I'll stop a server, update its code, and then start it again, and it'll rejoin the cluster, and then I'll move on to the next server. And once I hit all the servers, guess what? We've updated all the code without the game ever going down. Okay, see you, Arctic Space Fox. Good night. Yeah, I'll see you later in Togglebyte stream, probably. So anyway, that's what we're doing. The process you're seeing here, this is called the heartbeats. And if I do like a request, now it's doing an append entries. We're actually adding entries to everyone's copies. And that's the part I'm working on right now. So this is if you receive a request to update the log, we need to look at the log entries we received and kind of match them up with the ones we already had, because there's a lot of different possibilities here. The server could say, append these new entries, and then the receiver might be like, I already had those, so I don't need to do anything. The server, the leader might say, append these entries, and the receiver might say, I can't do that because I'm missing something that came before that. Another possibility, the one I'm working on right now, is that we receive like 2 entries, but we already had the first one, and we only need to add the second one. So in order to do that, we have to find where does our log match up with the sender's log, and so can we append the new entries, and which ones do we append? And hey there, M3, how are you doing? So this says for every new log entry, if we have some log entry for the previous index, we're going to verify previous entry terms match. If we don't have one, then we just then this is the case where I think we would just append here. This means that we have every entry up to that one, right? So actually, we still need to verify the previous match. If so, simply continue. This one is if so append entry. And then this is the case where we neither have the previous log entry at all, and the last one doesn't match. Actually, I guess we could have done this one first, right? No, we can't do that one first. So we have to check both of these. Thank you for the follow, by the way. I believe the servers communicate over WebSockets. Oh, are you sending all this data over a stream? When it's integrated, yes, they go over WebSockets. So in that visualization, each one of these circles is a message over a WebSocket. In the crate that I'm building, though, it's abstracted away. I kind of went over that earlier, but I don't mind doing it again. When you make a server, it creates 2 channels. MPSC stands for multi-producer single consumer. So these are like pipes, one directional pipes, right? One pipe called the command, or one channel, pipe and channel, same thing, right? I call it a channel usually. One channel called the command channel is how we send things into the server. So the things we might send in, let me see if I can show you that. If I go to this, one thing we can send in is telling it to configure, or telling it to mobilize, or telling it to process a sync item. A sync item is that, hey, we received a message for you, right? Please process this received message. So that's everything going into the algorithm. And as you could probably guess, the other channel is how the server tells us what comes out of it. So the events, how do I show that? Go up to here, go to here. An event could be, please send a message to someone else, or, hey, I just changed state. The states we have are candidate, follower, and leader. The leader is the one that can add new log entries that didn't exist before based on like client inputs or the state of the game changing, for example, on its own. Follower is when we're listening to a leader and basically making copies. And a candidate is what you have when the follower is absent or crashed or stopped. And then you've decided that, hey, I would like to become the leader based on the fact that my timeout expired first. So you go into the candidate state and you ask for votes, and if you get a yes vote from the majority of other nodes, you then become leader. So every time our state changes, that's an event. Every time we need to send something out, that's another event. So that's at the API boundary between my algorithm and then the rest of the system, which in my case would be the game. The way my game would handle a send message would be to take this message, serialize, and send it over a WebSocket. We pick which WebSocket based off of this receiver ID. So we'll have, like, if we have 5 game servers, each server will have 4 WebSockets open, one to each of its neighbors, right? And we'll have that in a dictionary somewhere, with the keys being the IDs of the other servers. So when Raft says event send message to some receiver, we'll take that receiver, look up which WebSocket goes with it, take the message, serialize it, and send that as a binary message over that WebSocket, right? Other direction is when we get something back on a WebSocket, we'll say, hey, which WebSocket sent us that? Okay, then we have the sender ID, right? We would take that sender ID, we would deserialize that message from it, assuming that it deserializes correctly. We would generate a receive message sync item and send it into the sync. So I'm using these terms stream and sync, or commands and sync items, because in Rust, one way to operate on a bidirectional value that has bidirectional I/O asynchronously is the output can be modeled after what's called the stream trait, which is an extension of futures. It works like an iterator, so it has an item, but instead of it producing the items synchronously on demand, it does them asynchronously. So it's going to be a poll next instead of a next. So poll next and poll is basically how the asynchronous machinery in Rust works internally. If you read about futures in Rust, you'll inevitably learn about the poll type and poll next and poll ready and all that stuff. On the outside, though, what we do is we just call next, and next is asynchronous, and in the internals, it converts a next into a poll next. So this is receiving output, right? So when we try to get the next thing that comes out of the server, we're ending up going to the event receiver and saying, hey, tell me when you have something. When you have something, then go to this context and wake it up. And it will then grab the next thing out of that event receiver, right? This poll next is basically delegating to poll next unpin. It'll either get the next event, or it'll be told there's nothing there, and I'll call you back when there's something. So sync is the opposite direction. It's kind of also like an iterator, only in the reverse direction. Instead of the type being of the item being an associated type, it's actually in sync as a generic type argument. So, but it's basically the same, only in the opposite direction. Instead of getting events out, we're sending sync items in. And right now, the only sync item is a received message that we want the server to deal with. But there might be other kinds of things that we might send the server later. So that's why I kept it open. If the only thing we could receive was a receive message, I would just get rid of that enum. And then this would be the sync item, is message with sender ID, and then this one, which I'm using to help the tests be a little bit cleaner. This is a channel that we use in the reverse direction, saying once we've received the message and processed it in our worker thread, we're going to send to this one shot. So the caller can just wait on that one shot, and then it'll wake up when the message is received. Sync is a little bit more complicated. I don't know why they designed it this way, but there are 4 methods. The flush and close are always ready when we map it to an unbounded MPSC channel. So the only thing we really need to implement is poll ready and start send. Poll ready is just forwarding it, so easy peasy. And then start send is also forwarded. There's a possibility that we could crash if the command receiver is dropped. That shouldn't happen in my design because we hold on to the command receiver until the whole server is dropped. But in case I have a bug, we would catch it here. So anyway, that was an overly long explanation about how we're handling the data and how it maps to WebSockets. So you could reuse this crate with something other than WebSockets. You would just have to define when, like how you receive a message. But however you end up doing it, once you receive the message, you forward it to the Raft through the receive message sync item. And the opposite direction, my crate defines a certain event called a send message. So when you get that, it's up to you to like send it however you want. The algorithm will help you out by telling you what to send and who to send it to, but that's about it. So it's separation of concerns. And it's an abstraction layer. So which is what you should have in an API, I think. Okay, so back to this problem. We're trying to handle to do finding the first match. Don't just blindly append an entry. So with this logic, we'll only append an entry if we don't have the... hold on. Is this right? Yeah, if we don't have the previous one? This isn't right, though. I don't think this is correct. This looks up, and if we actually have a log entry that for the previous one, we're supposed to see that the terms match, and if so, it's not simply continue. Oh, right, we need to do this. That's right. So this is technically not even correct, right? Or I should reverse these two, really. Yeah. It needs to be the other way. If the previous index is the last one in our log, then we need to verify the terms match and so append, right? Append. If it doesn't match, that means it could be greater than or less than, right? If this is less than that, then we need to verify that it matches by looking it up and seeing. But if it's greater than, then we don't have enough of the log, and we would stop. So really, what I want to do is do a match, right? Match this one compared to this one. And then if it's equal, so if ordering equal, do that. If it's ordering less, that's the easy one, right? That means this one is less than this one. No, that's the more hard one. This one is where we have to verify the previous terms match. And we're not needing to append anything because if it's less, that means we already have the entry. We just need to make sure the terms match. Right. But if it's ordering greater, that's the easy way out. That means that... Oh, I had this backwards, sorry. That's greater and this is less. Yeah, this means we already have... Oh no, I'm getting myself confused. This is their index. This is ours. If theirs is less than ours, that means we should already have it. If theirs is greater than ours, that means we don't have what it's based on, and so we have to stop, right? Break. Yeah, all right, that's what I want. What's wrong here? Oh, it wants a reference. There you go, have a reference. Okay. This we need to advance by 1 each time. So we would say that plus equal 1 every time. Right? So presumably once we've added 1, every time we're going to go in there, it's going to continue to be equal. and the previous will match because we just appended it, right? So to check that the terms are equal, we would say if previous log, so that would be append entries dot previous log term equal to self.log.last term. If that's true, then we append. If it's not true, what do we do? I think we break. That would mean our logs didn't match, right? And I might be off by one there. We might want to subtract one from previous log index, because we're supposed to return a match index when all is said and done, right? Yeah, we're supposed to return a match index. Right now we're just returning that, which is not going to be correct here. Actually, what we would return here, we would always return, if we broke out, we'd always return previous index minus 1, wouldn't we? Actually, not necessarily. I think we would return that. In this case, right? Yeah, so get rid of this. Break that. So this break should match this to, it should put it there, right? Make sure that I got this correct. Yeah, because that break matches that for, which gives us, which means this value is the value of that for loop, which is the value of this else, which goes into match index. Okay, so that's the last match if we do that. It probably doesn't like that because I haven't marked this as to do yet. We're not done, we just mark it as to do. Break with value from a for loop can only break with the value from inside loop or breakable lock. Oh, I didn't know that. The dog has detected an intruder. If and else have incompatible types. Oh, that's because of this other error. And this is a problem why. It's unreachable. Oh, because of this and that. Yeah, thank you for the follow. I need to take a quick break to drink something. I expected I expected I would be able to break out of a for loop, but this is telling me I can't, right? Breakable block. Okay, I could use break on its own, but I need to get the value back out. So I guess what I'll do is I'll have a match index and start it at that. Okay, I'll put in there even though I'm not confident in this match index. We want to start it out at this one, right? I don't know about this. Because here it's correct. Because ours is less than theirs, so we need to return that. If theirs is less than ours... Well, let me handle this one first. What do we set here? If they're equal but the terms don't match... I guess I want to tell it to go back one, right? So then match index is previous log index minus 1. What if it's 0 though? If the index was 0 and the terms didn't match, actually that's not possible. If the index is 0, the term will always also be 0, because 0 index is a placeholder for the beginning of time, essentially. So if this is 0, it'll always if this is 0, then this will also be 0, and same thing here. So it should never go into that else. So this should be safe, right? If not, we'll get a panic, I suppose. Yeah, so if they don't match, we need to say the last place we do match is the one before that. Okay. And then if they do match, we append the entry here, right? So then match index equals well, no, we already started at that. So it would be we don't need to change the match index, do we? That means I want to advance the match. If we get to here, we want to advance the match index too. No, we only want to advance it here. So I do want to add one, but that's the last thing we do. Right? I don't know. I have a feeling I'm writing this poorly. We need to verify the terms match, which I did. So we need to append the entry. So to append the entry, be self.log.append one log entry, a new log entry. And okay, this has to do with these. So it's no longer a to-do. Okay, so then, yeah, we're going to yield the match index when we get to the end. So I don't need that. All right, so I just need to handle this one then. If their index is less than ours, we need to look it up and see if it matches. So if append entries.previous log term equals self.log index, do I even need... Oh, no, I do need it. So it would be, you know, I can't look at that, can I? I need to look at something else. This has to be new log entry term. Not that. Yeah. That dot term. No. We need to look at the one before it to see if it matches before we can append this one. Here we have to look at the same one. Yes. So here I need to put if new log entry term equals previous log index plus 1 dot term. So I haven't actually defined what the index operation does yet, but it's going, what I wanted to do is borrow the log entry that's in the log. Oh, it's possible that it might be before the base, so that's another thing I have to consider. Yeah, I should say if previous log index is greater than self.log.base index, then we can do this. What happens if not? That means that this could be well, actually it's another match, because if it's equal, it's another special case. Okay. Yeah, another match. This dot compare that. Should I do the same thing if it's equal? Actually, I feel like it would look nicer if it was less, equal, greater. So less, equal, greater. So if their previous log index is less than our base, I think there's no way we can match it. It precedes our snapshot, so what will we do there? I think we just ignore it. So we would continue, so we would do nothing. Yeah, we can't know. Yeah, it's pointless. If they're equal, then this is all just getting the term, right? Let previous, well, can I say term? Option, no. Let's just do it here. Let term equal self.log.base term. Otherwise, let term equal this one. Actually, if we're always going +1, then maybe I don't need a match because equal... am I off by 1 here? Let me think. This is tough for me. Anyway, this would be outside the match, right? Oh, shoot. No, it's not. It would be in here. Okay, I gotta clean this up. But yeah, this would be if that and another one here, which is redundant right now. Double equal, double equal. Previous, so this is their previous log index, how it compares to our base index. If it's before our base, we can't make a decision. If it's equal to our base, then we compare the previous, right, so it's not this one at all. Well, no, that is that one. No, it isn't. Ah, shoot. This is so confusing. Ah, arg. I think I need to track the term too. Previous log term is append entries dot previous log term, and then that needs to get updated as well. Yeah, okay. Ah, so confusing. Yeah, after this, we would advance it, right? Previous log term equals new entry dot term. Oh, wait, no. That goes down here. Does this one own the value? This is gonna be a trouble. I'll probably want to do a clone here, right? To avoid a clone there, I need to capture this earlier. So let's do it this way. I'll up here say let next log term equal that, or new log term. And so down here I can just say new log term. All right. This is gross. This is really gross. Feel like I've approached this from the... have the feeling that you approach something from a problem from the wrong angle, and then you just need to take a step back, maybe delete the code and try again? Yep, you too. A lot of the time I'll just push through it and then refactor and then realize my mistake. Way too many times? Yeah, and hello, by the way. Equine and Dev. Man, I can hear everybody in my house at the same time talking. Maybe it would help if I had comments here. Their entry predates our first... Well, we should have their entry. This is the next entry to append. And this is, we don't have the entry before this one. So this is all just making sure that the term matches, right? So in this case, the entry was folded into the base snapshot. This one is, the entry was the last of the base snapshot. So we look at the base term, right? This one is, the entry should be in our log. Well, the entry is after the base snapshot. So then we can look it up in the log. If it's exactly equal, we look at the base term. If it's less, we can't do anything. So we just assume that it's good. Like this should work, then too many edge cases, and then all spaghetti code. Yeah, this is a spaghetti code ball. I'm hoping that when I'm going to use these comments to help me through this, I'll get it and then I'll refactor it, because I can already see there's going to be some redundancy we're going to want to deal with, right? So if we already have this entry but it doesn't match, then what do we return? I think we would just have to return 0. There's no way we can get a match. I'm using 0 for match index, but the white paper talks about there being a success flag, which you set to false if you can't accept the entries at all and you can't even give a hint about where they might start matching. Can't understand it. Leaving the code behind after 6 months is not easy enough to understand. Yeah. So I hope to get this into a state that I can come back to it 6 months from now and make sense of it. Right now, I would not be able to do that. So if they're equal, then it's good. So it's really the not equal case that we care about. And we would want to break at this point. The same thing here. So one way I could do this is I can say if this, then break. And then this is false. And then reduce this to just that. Oh, I need to have the match index 0 there. And the same thing here. It's just that. It's really messing up my comments here, isn't it? Do I allow it to do that? The formatter really doesn't want me to do that. It wants to do that. What if I put the comment before here? Can I fold that back? Yes, I can. So that's maybe better for now. So just put it before that. So I can collapse this then. Okay, so when it is the next entry to append, we would compare their previous term with our last term, and then append it if so, and advance the match index. Correct. If not, then we need... Do I need to do that? Isn't that what it started out as? It starts out as the last index. Oh. Wait. The previous log index going to be... Oh, right. If the terms don't match, that means we need to tell it to go back one. Yeah, this is an optimistic assumption, really. Where do I use that match index? Do I ever actually use that? Actually, I don't. Oh, I see how I can handle this then. Thank you for that follow. I could just say match index equals that, the return of that match. Oh, thank you again. Only, I want it to be on this, but we can't have, right, that's the problem, is we can't have a value for a break out of a for loop, can we? There's probably a way to do this without a for loop, then it will allow me to give the value in the break itself. So that means I really don't care about that, so this is just optimistic. Forgot to follow last time? That's fine. Thank you for the follow. This always advances by 1. We always get the previous from the new one for the next time around. And if we break out, then match index is our last match, or 0 if we couldn't find one. I think the way I would make this readable is I would put these into functions. So this function really, what it's doing is verifying that we have the same history in our snapshot. No, not just in our snap. It's either in our snapshot or in our log. So this is verify common history. This one is verify last. It's an extension of this. Maybe can I fold this into here? Like less or equal? If it's equal, do any of these make sense? Actually, maybe it would, because last term should be that, I think. So we would see if the history matches, and then if it's also equal, then we would append one and advance the match index. Yeah. And then do I need this else? I think I do. That's how we know where the last match was. Actually, if I move that to the top here, then I wouldn't need that, because the only other time we break is to set it to 0. So then, yeah, I can initialize it to that at the beginning. Right? That minus 1. But if that's 0, we have a big problem, right? Shoot. Can I do a checked sub? Or unchecked sub? And that gives, unchecked sub gives me an option out, right? Or what was it? Checked sub gives me an option out? Yeah. Oh, we can do that. Checked sub 1. Or... is it okay or else? Unwrap or. 0. There we go. So we'll take the previous one and subtract 1, but if that would have underflowed, we just set it to 0. We would only set it to 0 if they don't have any previous history. We might not have any previous history either, in which case it would be equal. And we'd still say match index 0, which is fine, right? Maybe this is off. Maybe I'm not supposed to subtract 1 there. Wait, when am I looking at the current? No, I don't need to look at the current term. We're always looking at the one before. If the one before is in, is not our last one, we have to look it up, either in the snapshot or in the log. If it is the last one, we look at last term. That's correct. Why did I add 1 here then? I have it bad. I don't like these -1 +1s. Entry is after the base snapshot, then if that's the previous one. Why am I adding 1? This is wrong. I shouldn't be looking at that new log entry term. Should I? Oh, wait a minute. No, I am, because we should already have this entry. So we're looking for the next one. So the next is always the previous +1. Okay. That makes sense. This means we don't have it. This means we should have it. This one, these are that we don't have it. If we don't have it, then we're looking at the previous one and seeing if that matched our last one. Yeah. Boxstein trait is your new friend. I actually used that when I was making this log trait to define the iterator. Because you can't have a trait with a function that's generic. Otherwise, it would have made this generic over any kind of iterator. Where as long as the item is that. But you can't do that. So boxing it lets you do it without making append generic. The cost is that the caller has to box their iterator. So the iterator ends up getting copied onto the heap. In order for us to do dynamic dispatch through the vtable of iterator. It is pretty neat. Gives you a vtable, allows you to do dynamic dispatch, frees you up so that you don't need to make the method generic. But the downside is the runtime cost. Ecton Dev, 7 months in a row? What happened to my overlay? Oh, it was just lagging behind. Thank you for the resub, Ecton Dev. I appreciate that. I'm struggling with this, and I think the solution is I'm going to break this up into functions to make it clear what this means, what ordering less means. Ordering less should mean compare history, compare log history. Ordering equal should mean compare... Actually, this is another form of history, but this is like check that we have a log entry. This would be check that the last log entry matches theirs. And this means we don't even have the one before this one, so we can't add it. Okay, so the only bug here is that my log doesn't implement the the trait that I needed to do. So we're gonna base it off of standard ops index. I can't do that. What's there? I thought I would be able to do that. Oh, it needs a type argument? Yeah, index command. I can't do that either. Self command. You can't do that? Cycle detected. Uh-oh. So you can't have a trait be constrained by a generic trait? Then I'm going to abandon that. We'll just have to not use that operator overload. So instead, we'll just invent a new method called get. I'm thinking in my head, should I make get fallible or not? I'm thinking no, it should be infallible. Well, no, we ought to make it fallible because it's across an API boundary. So let's add an expect at this level. Expect log entry blank should be in log but isn't. This number. And that... Can we do a format and an expect, or do I need to... I mean, does expect do formatting, or do I need to do the format thing? I'm not sure, but let me add the get first. Get alphabetically would go here. Get self index usize gives us an optional log entry self command, right? Doot doot doot. There we go. What? Found 2 arguments? Oh, is it this one? Okay, so I do need to do a format. And this is wrong Y. Found a string. I need to borrow that string. Or technically, if it says it wants a slice, I learned this the hard way last night, right? If it wants a slice, I should do as str. I ran into a case last night where it needed to be that. How come it's not formatting this? Is it because it's inside of a macro? I guess I'll do it myself, so that... I think, yeah, because it's inside of a macro, it really isn't helping me. No, it's because of the complexity of this mess, which, yeah, confirms to me that I need to refactor this. Let me get it to work first, though. Log term is never used? Really? I never used that? Use log term. We should have used that, though. Oh, yeah, this is where it should be used. That's wrong. Okay. This append entry should only be used up here. It shouldn't be used inside the loop, because that would be a mistake. Let me move that outside there, because it makes more sense. So then I can take this and put it like there. Remove that. All right. These comments are only there until I make methods to make it more clear why. You know, what greater, equal, and less mean in this case. Expect followed by a function call. What? What does it mean, use of expect followed by a function call? I'm glad they give me something to look up, because maybe my brain is not working. Oh, really? It's always called? Oh, I forgot about that. It's telling me it's always going to format the message even if it doesn't have an error, which would be inefficient here. So yeah, it's unwrap or else some function. And that we want to do a panic, right? Yeah. Or else panic that. All right. So then it's lazily executed only if we couldn't get the log entry. All right. Mock log doesn't implement that, so I'll have to add that. Control dot, implement missing members. Save, and here it is. Let's put it in alphabetical order. I wish it would do that for me, but it doesn't. Okay, so get... It'll be in entries, but we need to subtract base index first, right? So we would say let index equal self dot, well, index checked sub self dot base index. Oh, I forgot. This, it needs to be thread safe, so I actually need to push it to the inner shared part because there's a front and back end to this thing. So it needs to be share.get index. And then the version in the shared looks like that. Up here somewhere, right here. And this is dummy command, not self command. Should probably save this down here too. Actually, no, that's self command. This one's definitely dummy command, right? Yes. This is not generic at all. That's just base index. Check sub base index dot map, right? Map. So yeah, I don't need to do a let. Map index to looking up the index. Otherwise we get a none if it underflowed, right? And then I need to take self.entries. Is there like a checked get or a get? There is a get. That's what I want. Get index. I think that's it, right? Oh, it's an option. So that's because I used map, right? So it should be and then? Question mark? Okay, almost, but... Oh yeah, this should borrow. Get should borrow, not give us a value on the way out. So the trait needs to say borrow as well. Yep. What's wrong with this? Oh, shoot. So we need to clone it then. Oh, bummer. It has to do with the fact that we're going into something that's shared. So, yeah, it could be overridden or moved. Dang. So we're going to always clone when we do a get? That's going to be expensive. If the only thing we need to get, though, is the index, what if I make a get index? Or just say entry index. Yeah, let's just do that for now. Entry index gives me back an optional usize. Or entry term, I mean. Yeah, that's what we're going to do. So it's going to be entry term optional usize. Entry term there. entry term, optional usize. So then it's that. This one would be a map entry to entry.term. There we go. So subtract the base index from the index, and then get that entry and map the entry to its term. All right, I like that. And then this is just a wrapper for that, and then so I don't want to do a term anymore. We just do get. Oh, entry term. Correct. Okay, and then what's this warning up here? Manual saturating arithmetic. Oh, is there another method I didn't know about? Probably. Let's learn from Clippy. Saturating sub. Okay. Yeah, that's what we want. Saturating sub. Is that from another trait? Or no, there it is. Saturating sub. That's what I want. Hey there, Smack in the Box. How are you today? And Papata still Papa. I forgot to say hi to you. That was a while ago. All right. Feels like a slow Monday today. This is going to continue not to get formatted until I refactor it. So let me put a big fat need to refactor on this. To do needs refactoring to make Rust FMT happy again. Yeah. All right. I just wanted to make sure it works. Hey there, Fallout Ghost. Or Fallout Ghost. Hi. Let's run the test that goes along with this. It failed. Why did it fail? It got a 0. Ooh, that's bad. What's the task? Today we're working on Rust. Or we're working on my Raft Consensus algorithm implementation in Rust. Raft itself is a consensus algorithm. I won't go through the whole intro again, but I'm implementing an algorithm in Rust that I have already implemented in C++ that forms one of the core pieces of my game, which you can get to here, which is inspired by the old games like Ultima 4, Ultima 5. The game's infrastructure runs on a group of servers where one of the servers runs the game and the other two are constantly keeping copies of the game so that we can take the leader server offline, or if it crashes, and the game will still continue to run and we won't lose any information. The algorithm that lets this work is called Raft, and I'm working on that today in Rust. Since I'm in the process of porting my game's backend server from C++ to Rust. Yeah. And I get the words Rust and Raft confused all the time. So there are two main parts of the Raft algorithm. One is to select a leader, and the other one is to replicate the data. So this is the data replicating part. So if we start out with our data being just one entry from term 1, and the leader of the cluster gives us that one again, and then a second one, we need to make sure that we should only end up with 2, because this one should be redundant with the one we already have. So that's what the unit test is saying. The unit test says, start with one of them we already have the pretend server resend that along with a new one, and then we should only get one new one added. And the way you can tell that this should match this one up here is not only does it actually match exactly the term is the same, but also the index in the log is the same. So the index this is 1 because it's the first one, because index 0 we reserve to be before the history started. And so this previous index has to match our previous index, which is going to be, for this one it's going to be 0, because this is at index 1. A little bit confusing with the words term and index, but they all kind of match up if you follow that link to Raft and you look at, like, here's an example set of states. If they also number from 1, so that all the entries from 1 to 4 in the log are term 2, and then starting with index 5, you have term 3. So this is the log. It's a sequence of entries, and we're representing it in code like that. Now, to make an actual game out of this algorithm, the term is the only thing that the Raft itself requires to be in the log entry. So what I did is I left a placeholder called command. So in my game, a command really is a command to the game saying, make this change. So in my game, a command could be create a monster, or destroy a monster, or move a character left, or move a character down. Any kind of microscopic level change to the game will be captured in a log entry where the contents of the command is what the game uses. Raft doesn't care about that. It's more of like a payload for a container, and Raft only cares about making sure the container is replicated, right? And the only other thing besides the fact that it replicated that it cares about are these term numbers, and the index is where it is in the list of changes. So focusing sort of just on the Raft algorithm and abstracting away the concept of the game, but how the game would plug into this is through these commands. And in our tests, they're going to be either placeholders or nothing, because we're only testing the Raft part, not the rest of the game. I hope that makes sense. So the bug I have is that we're getting a 0 out, which means that it didn't think the previous one matched at all. So let me think about this. We start off with nothing. We append one entry. So the last should be 1 now. It was 0, now it's 1. The last index is 1, and the last term is 1. Oh, maybe I didn't update last term. Let's look. Mock log append. What does it do? It does copy the term, right? Before it pushes in it. So it should be 1, 1. And then it goes into the server, both of those entries. So that's 0, 0 from the test, right? 0, 0. And this will saturate sub 1, which means this will also be 0. And then it's going to go through the 2 entries that we appended. And it's going to take the first one's term, which is 1, and it's going to try to match up this previous index, which is 0, with that which is also 0. And so it should go into the equal case, right? And then this will be... Oh, okay, that's the problem. That's 0, but this is going to be 1. Yeah. It should go into here. Oh, wait, no, this was wrong. This is 0, but that's 1, right? So it should go into here and then compare 0 with 1 again. So it should go false. And false was for... What was that false going to? Actually, don't know where that false is going. Oh, it's if, right? So it's gonna not do that, but it did. And maybe I need to debug this. When stuff gets confusing, you just break out the debugger, right? That's okay, Falgus. You didn't distract me too much. A lot of people come and go. I actually like it when people stop and ask what I'm doing, because a lot of people don't. A lot of people come in, have no idea what I'm doing, and not have the courage or, thought to ask, and then they go away not understanding what I was doing and probably never come back. So if people ask me what I'm doing and I explain it, then maybe some people say, okay, I sort of get what he's doing, and then it becomes a little bit more interesting. So when we're in the debugger now, watching what's happening. So previous log term is 0 and 0. Match index should also be 0. Well, that's interesting. Why is it a huge number? Oh, I might have shadowed that variable somewhere. I think I did shadow that number. That's the problem. Yeah, we're looking at that variable, not that one down there, I think. That's a problem in the debugger. The debugger doesn't know about shadowed variables. You're more C, C++, C# programmers, so don't ask me anything about Rust. I didn't know anything about Rust until about August of this year. Before that, I was doing C++ for like 15 years? Really long time. Okay, so this, it should go in. The new term is 1. So it should compare 0 with 1 and go into less. Slick for 18 months? My math serves me. 18 is 2 times 9. So that's a second baby rage. Thank you for the resub. You've been here a long time, Slickver. I think you're one of my oldest subs. You're one of the few remaining founders who haven't abandoned me. Sniff, sniff. And now, yeah. Yeah, anyway, I shouldn't say anything. But thank you again, Slickver. So that should return us 1, so it should go into less, right? False. Wait a minute. Why did it go into equal? Wait. Oh, the base is 0. Right. This is wrong then. It should be equal or greater, because I wanted it to go in there. Don't I? We should already have this entry. Doing JavaScript almost exclusively the past 3 years? Great. I am using JavaScript also in the front end of the game. Front end of the game. This is using React. This window is using Phaser. And I pulled together the state using Redux. I almost forgot the name of it. Yo. Yeah, so each of these segments of the DOM is a different React component, including all these buttons. It'd be really nice if I could see these variables, but it's going to be hard to see that. Like streams like this are a good way to stay open-minded. Yeah, you would at least look at this and say, wow, that syntax, I hate that, and so you'd know not to go into Rust. Actually, you should look at this and not judge Rust, but you should just judge my coding. With the knowledge that I always write really horrible code the first pass through, and then I kind of clean it up later with refactoring. I'm not good enough yet to write code that is clean on the first pass, and I don't think I'll ever become that good. Let me think about this. So we should already have this entry, right? So what are we doing? We're comparing the previous index with our base index, and they're going to be equal. And then we're saying, okay, then look at the new log entry's term. This is wrong, isn't it? I should be looking at previous log term and comparing it to the base term. Yeah, that's the problem. This should be previous log term. And this should also be previous log term, shouldn't it? No, for this one, it's after the base snapshot, so we can actually look at it by looking ahead at it. That's right. Yeah. Well, wait a minute. If the previous index was that, then we can look at index 0. Okay, so then equal and greater should both go into that arm. Yeah, that's the bug. So I don't need a match here. I just need to say if it's less than, it's false. If it's less than that, then entry is folded into the base snapshot, right? So it's just false. Else, we compare the terms. Yes, like that. Well, this should not be folded into. The entry was in the base snapshot, or is in, or was. Actually, the original statement was correct. The entry was folded into the base snapshot. The entry is after the base snapshot. And then we do that. And whoa. Yeah, this is going to be a formatting nightmare for a while, isn't it? Oh wait, what are we doing? This should be if it is greater than or equal to the entry is in the base snapshot, and then we can compare it, right? And then this here should be if that, then break. I think. And now what is it telling me here? What did I do wrong here? Avoid complex blocks or closures with blocks. Instead, move the block or closure higher and bind it with a let. Blocks in if conditions. Oh, it's just saying that it's too complicated. So I should move this out and say give it a name. What name should I make it? This is like existing log entry. I'll just say term. If they're not equal to them. Oh shoot, I completely fudged that one up. Is that right? Okay. So then we need to grab the term. It's possible that we might actually have it if the log screws up. This shouldn't happen, but if it does, because it's not in our jurisdiction, it's in that of the log, which is a injected dependency. If they screw up, we need to panic. But they shouldn't. We should be getting the term from the matching entry, and if they don't match, then should we say 0 here? I'm feeling like this is not correct. We should have it go to previous log index, right? Why do we back up by 1? And then, okay, yeah, maybe we should not touch that then. Yeah, the only time that we don't have an entry before this one. No, there was a... Okay, where do I set it to 0 then? There was a condition where I set it to 0. What was it? Where, it's less... No, I think this is fine. We never need to say 0, right? This is... We should already have the entry. If it's in the base snapshot, then we can't even check to see if it's correct. We can only check if the entry is after the base snapshot, and then we say, well, is its base, is its previous, does it match? No, is the entry that we just got, does its term match? No, there's something still wrong about this. Something's still wrong. I think we need to check both the current term and the previous one, don't we? Yeah, I think we need to check both. So it should be, there's two conditions then. Actually, Rust doesn't like when you use parentheses, right? For two conditions. So it's if the previous log term is not equal to, oh, and then the, yeah, this is, if this is new term, I need to have a previous term. That's where I'm going to run into trouble with the log. Although I guess we could say entry term, if it's exactly the base, it could return the base. We're going to be checking things twice this way. This is not that efficient. That's okay. I'll clean this up later. It's gonna check two different indexes. I hate this already. It's gonna look up the terms of the previous one and the current one, and then compare them both, right? And if either one doesn't match, then we don't like. Oh, right. If this is not correct, then we have to bail completely. Match index is 0 and break. This one, though, we just break. This is, we have no, the history doesn't even match. This is where the entry doesn't match, so we can just stop at what we had already at match index, so we just stop. Okay. Try again. Run it. And we crash. Panicked, unexpected end of... Oh, log entry 1 should be in the log, but isn't. Oh, my mock log is broken then. Oh, because of the border case, right. So yeah, I need to check if index equal self.base index, then it's self.base term. Else it's this. No parentheses. So drop the parentheses. Sum, right? Because it's an option. All right, so try again. Another crash. Is this the same crash? It is not. It still says log entry 1 should be in the log, but isn't. Why is it saying that? Bases. Oh, am I off by 1 when I think about it? I think I might be. Yeah, this is, their get is 0 based, right? So I need to subtract 1 from index. Yeah. What if it's below what we expect? I guess we don't need to worry about it because the server should never, it'll panic if it underflows, which is what we want. Okay, unexpected match index this time. Was 1 should be 2. Okay, so that means we got past the first part. It at least moved the match index to 1. So it must have advanced it here. Oh, wait. I need to advance it. Yeah, sorry. I need to advance it in all cases if it doesn't escape, right? Let me think about this. Yes. So it should advance it here. Except for that. Oh, but that's a break, right? Yeah. So I don't need to do that because it's auto-advancing every loop. Yeah, all right. Really need to refactor that now. Wrong term in vote? Why is there a vote? Oh, that's the wrong message. This shouldn't be vote. Append entries. So the term number is wrong. It should have been 0. Wait, no, it shouldn't have been 0. Okay, that's wrong. Expected term should be 2. So what's wrong with my test here? Why do I have 0? This should be... Oh, wait a minute. I said it should be 0 because it should be what our term was when we received the request, right? So maybe that's not what the code actually does when it computes the response. Yeah, it's returning what it is at that point. Problem is it would have updated it here. Okay, I need to look at what the white paper says. Do we return what our term is, or what our return or was, or what it is after we receive the message? That's the trick. So I'm gonna find that white paper again. Raft white paper. Sorry about the blinding white. Adobe Acrobat Reader doesn't have a dark mode as far as I know. Reply false, reply false. Okay. Current term for leader to update itself. If a request or response contains a term greater than set it, convert to follower. Okay, but what do we set? Do we set it... This, do we set current term... Do we return current term before or after we update it up here? I guess it doesn't really matter. We can just... Okay, I can just change my test expectation to say, okay, we'll expect it to be updated to 2. It's okay if it's equal. RASPEC would just send back a success message for that entry. Oh, thank you for the follow, by the way. Sorry I lost the context of that. The problem is that we're doing multiple comparisons here, right? I'm comparing the a previous index, and I'm also comparing the terms. I'm comparing indices and terms as well. Hey, Sarah, 715209, how are you today? Once I get this test to pass, that gives me license to refactor, right? Okay, it passed finally. So now I can clean this mess up. I think the first thing I want to do is extract some methods to explain what the heck's going on. And this is... I really need to fix this redundancy. I think I can do an initial previous term check. Right? It's like we're lining up 2 histories and saying, okay, does the previous one match? Now does the current one match? Now advance one. I don't need to look at the previous one again because we've already advanced. So what if I say like, well, I can't, it's hard to combine these blocks because there's a difference between +1 and not. Suppose I can make a helper that does this unwrap or else for me. So a helper that grabs me the term of a log entry, and it'll handle this on wrap or else for me. It's just that I hate the idea that we're comparing previous. We should only need to compare the first time. Then, as we're tracking history, we just compare the new ones. When we get to the ones we're appending, we're again back to comparing the previous ones. I can't think of any way around it. Maybe just leave it in there. There's just too many corner cases, because we could start where it is less, or we could start where it's equal, right? And if we start where it's less, then this will be down here, the first previous term comparison, the first time it goes through. But if we don't go through less, and if we go through equal, we need that. So we need both of these, definitely. But we only need to do this one once, but this one has to be done every time. Okay. I think I'm just going to keep it, but I do want to make a helper for that. Let's call it something like log entry term, self index usize. We get back a usize. Self log entry, so this is index, unwrap or else log entry should be in the log but isn't. No semicolon. All right, so then that goes in two places. Here for previous log index. And then again for previous log index +1. And then I could do that. Yeah, so I don't need that anymore. So we can only compare terms if it's after the snapshot. Right. If the previous log index, if we'll know the previous log term, the only way we know the previous log term is if the previous log index is the base or it's greater than the base. Rust is a good alternative to C++? I think so. Trickster. I could pull up those, what I like about Rust, right? It's suitable for general purpose programming. I like that code usually just works once I get it to compile. With the caveat that when you're unit testing, you're adding more constraints. But if you're not unit testing, stuff usually just works if... Actually, this is not even true. I wonder if I should just strike this clause that it usually just works, because I'm coming up with counterexamples of that all the time. Maybe should just say that it's strict and rigorous, and I get a sense of accomplishment when I get stuff to compile. All of these things are some of the benefits that I see. That in a lot of the cases you don't have these in C++, right? You don't have built-in unit testing or code formatter or package management or a linter or cross-platform stuff baked in. You can get a bunch of this stuff for C++ through add-ons, extensions, libraries, that kind of thing. But with Rust, it kind of just comes out of the box. Enums are pretty cool, which goes hand in hand with the option and result types. Very powerful way to mix error handling with the flow of data through your code. So that's pretty neat. So a balanced approach would be my not favorite features. So before you just jump into Rust saying it's better than C++, here are the reasons why maybe not so much. Very opinionated naming convention. Very terse terms. A lot of confusion over string types. Rigidity, kind of weird sort of rigidity with strings in that they have to be UTF-8 encoding, which is like good and bad, right? Certain design techniques like asynchronous closures, very hard to do. Not a whole lot of help out there on the web yet. A lot of stuff is still unstable in Rust, so you have to know the difference between stable and nightly builds of the tools. And some things you just have to get the nightly build for, like my formatting. Almost all of the options I want for the formatter are in the unstable build. They're not stabilized yet. So it's a relatively new language that has a lot of promising features that either aren't available in C++ or that have had to be added on to C++. C++ being more like an onion where it's got layers, things added over the years. And so it suffers from it not being at least a seed of those features being there when the language was conceived. If that makes sense. Rust has got like the seeds of ideas from a lot of different languages that are newer. So they take advantage of standing on the shoulders of the past, whereas C++ are so old that they're not, the language design wasn't as sophisticated back then. Also, C++ kind of suffers from having to support very, very old legacy code, so it's hard to change the language without breaking old code. Whereas Rust is relatively new, and they also have sort of baked in edition. Like every 3 years, there's a new edition of Rust, and so you can opt into sticking to an old edition of Rust, or you can move to the new one. I am disappearing. Oh no! It's because it's getting dark. I need to start adjusting my camera, and let me do that. I need to adjust the filter on it. Hold on. There, now I'm not disappearing. If I go too far back, though, you start to see the blue screen. Lighting is the hardest thing to get right with cameras. No problem, Trickster. Okay, I refactored this a little bit by doing what? What did I do to this? I did something to it. Wait, what did I do? Oh, this log entry term, right. So we're comparing the previous and the new. Cool. I kind of understand that, but I'd rather have a function do that. Is it? So now the formatter is somewhat happy. So let's move this into another function. What does this actually do? This is going to... Oh, what's this? Radon 90? Also 18 months? Good thing I have this prepared in my buffer. 2 baby rages for Radon 90 as well. Thank you for the resub, Radon 90. Did I get a haircut? Yes, I did. Mrs. Raimu cut my hair last week. She's been cutting my hair for the last 20 years. She's gotten rather good at it. If I make this into a function, the problem is I have breaks in here and I'm mutating variables, right? Well, I'm mutating this one for sure. Okay, I can put this directly into there, right? Yeah. And then I can do the same thing here. Okay. This whole thing becomes an if statement. Ultimately, we need to do one of 3 things, right? Nothing, break, or break and reset the match index. That tells me I kind of want to have an enum for that, right? And then do a match on it at this point. Thank you for the follow. So let's attempt to extract this function. This is like compare history. Compare log history. And I don't know what other arguments we're going to have, but it should be like history comparison. There. Get rid of that line and that one. Okay, so let's define what history comparison is. What are the 3 possibilities? Possibility 1 is that nothing in common. The other one is so that's the nothing in common one. This one is where common base only. And the case where it matches all of them is same. Well, same base only. And nothing in common. I like those. I think those names are fine, right? Okay, so this needs to exist outside of this implementation, so let's move it up to here. All right, and then back down here. This is going to return history comparison, nothing in common. This one is going to be same base only. Else, same. There we go. Say my kids want to pursue a career in tech. Yes, but not in software development, which makes me really sad. And they're all different, too. So not all of them are really interested in tech so much. It's also harder to tell for the younger ones. It's really hard to tell what they want until they get, like, into college. Gotta have a repeats itself variant. History repeats itself. So I need these variables, looks like. Index and term. What else? Comma. And then I need the new log entry. I only need it for its term, right? So new log term. Yes. Because the new log index would be the previous log index plus 1, so it's not interesting. Yeah, so this is new log term. What's wrong with this? Mismatch types. Oh, I should have else if. And then I would end up having that twice. So what if I have just make these returns? And then, yeah, then it's that. Whoops. Actually, there is a fourth thing, right? That it's unknown. I guess we're treating same and unknown as the same result. So we're being optimistic that if we can't tell, then we're just assuming it's the same. Okay, so given that, I'm going to use it down here to clean this up. So this should be a match self.compare history. That needs what? Previous log index, previous log term, a new log term, which is new log entry.term. Okay, history comparison, nothing in common gives us match index 0 break. History comparison, same base only just gives us a break, and then history comparison same is a nothing. All right. You're told in high school you shouldn't go into comp sci? Never did college for comp sci. It was digital design, believe it or not. Pick up programming from an electrical engineering point of view over a comp sci viewpoint. Hold on, I'm trying to understand what... I got confused at the end of that sentence. Sorry. Okay, so you were discouraged from going into computers in high school, but when you got into college, you got into electrical engineering, and they told you, okay, now you're going to need to get into computers. Yeah, well, strangely that they told you not to go into comp sci. Like, did they have some intuition that you would become an evil genius in computers, and so they told you, oh no, you shouldn't go into it. Kind of weird. I would think that in high school they'd encourage you to do whatever you were enjoying doing, and if you're enjoying electrical engineering and getting into programming that way, like, how is that different than showing an interest in high school? I don't know. Weird. We should have this in the entry, so we're going to compare the log history, and there's nothing in common. Okay, this is at least easier to read, right? What about this part? This is the next entry to append. Should this whole thing be in a subfunction? I feel like it should. Maybe history comparison should be more abstract and be like log comparison. And there would be another fourth possibility for this one. I don't know. And this has another side effect. So maybe I keep this out. I keep this here then. All right. This is probably good enough for now. To get better than this, I'll need to take a break and look at it with fresh new eyes. Your mind would go 100 miles per hour and skip syntax issues? Then you had probably a poor teacher, because syntax issues should never get in the way of computer science. Syntax issues really are just par for the course. Everyone has syntax issues. I have syntax issues with Rust all the time. What I chose to do is to set up the tools to help me out with that. So if I forget something, it'll add it back. See, I just delete it and I hit save, it adds it back. And I don't have to worry about if a semicolon is necessary there. If I leave off an equal sign, I get a red squiggly, and if I don't know what that means, it'll pop up and say it expected something, which sometimes tells you what the problem is, and sometimes it's really just a clue, and you just get to used to what the clues are. But yeah, syntax issues are kind of like a side problem you deal with, whatever works for you, either with tools or with memorizing the syntax. That shouldn't get in the way of computer science. Computer science is about the theory of using computers to model problems and let the computer solve them for you, which have nothing to do with syntax. So you probably were in a high school where they really didn't know what computer science was. They thought computer science means memorizing syntax, which is sort of sad. But I've actually seen teachers like that, who they're like, they test you on the syntax and they don't care about the theory behind the code. In fact, the code, usually it's absurd code examples that you never have in the real world. So computer science, I think these days, is more like a combination of problem solving and understanding algorithms and how they are applied to solve problems. The language you pick is just how to match your brain to solving that problem, telling the computer how to solve that problem. Yeah, then maybe it's a good thing that you didn't really get into comp sci until you got out of that, because they would have taught you wrong. They would have had you become a syntax snob and not really care. You should care more deeply about the code being an expression of expressing to the computer how to solve a problem. When you think about it another way, the syntax doesn't matter to the computer when it's actually running your program, unless it's an interpreted language. So let's say, for example, it's Rust or C++. The compiler only cares about the syntax when it's trying to compile your program. Once your program is compiled and running, there's no more syntax anyway. So why does it matter to what really matters? It doesn't matter in the context of what you really want the computer to do, which is to run the program and do something useful, right? Syntax is just, it's kind of like punctuation. Like if you have someone who like criticizes your text messages about the spelling and punctuation, and you're like, well, did you get the, even though I say, what is it? My mind's drawing a blank. If you say later, and someone criticizing you for not saying later. You're like, well, you read that and you understood it was later, right? So why does it matter if I use the letter the number 8 rather than A? You want your Rust to just work? Yeah, that's a brain wave translation into syntax problem, not a computer science problem. I really don't like this mess, but I think I'm going to revisit this later. So we did that now. Cool. Now, and we also did this one. And we also did this one. So what we're still not doing is we're not deleting oldest mismatched entries and all entries following them. Right, so we're saying what the last match was, but we're not going back and deleting out of our log anything that doesn't match, right? So we're going to need to make another unit test for that first. So this is where history doesn't agree with the leader. The leader will overwrite history. So this would be follower replaces mismatched appended entries. There we go. There we go. Later, like recursion. Yeah, that's... If someone is preoccupied with how to spell words and how to punctuate them, but everyone got the intent and meaning of the message in the first place, then they're complaining about something that's not important. You should tell them, well, as long as it's understood, why does it matter? Okay, so here I want to like put something different in here, right? Like a term. Let's have the old one say term 1 and the new one say term 2 and 3. So it should overwrite, when we say 2 and 3, it should overwrite the first entry with the 2. Actually, this might already work. No, it won't already work, because it's not going to replace the entry correctly. So this will fail, right? Yeah. It's going to say it didn't match at all. Yes. Okay, so let's fix it. So it's when we get our first mismatch that we can handle. That would be this one, right? So instead of breaking, we kind of want to we want to truncate the log at that point, right? So if it's same base only, we want to toss the entire log at that point. So instead of breaking, we want to tell the log to truncate to 0. Well, truncate to the base, right? Our base is their base. Previous log term, right? Previous log term. Or previous log index. There we go. So we haven't defined that method yet. So basically drop log entries after that common base. Nothing in common, we can't do anything about it. If it's the same, we don't need to do anything about it. Okay, and then when we get to here, at this point, rather than breaking, we can truncate again. Self.log.truncate match index. And then continue. So the only time we truly need to break is if there's nothing in common. Otherwise, we're going to truncate the log to where the first match was and then start appending entries. Yeah. Hey there, Irish John Gaming. How are you today? Slickver said something, so I can wave. Irish John said something, so I can wave. I'm waving at everybody. I forgot to wave till I like recursion. And I didn't see Greyjack. Oh, no, I did see Greyjack's question, but it was in the same color as someone else, so I forgot to wave. How am I doing on time? 2.5 hours? I need to define a truncate method now. Alphabetically, it'll go here, right? So this mutates the self, and we need to give it an index, usize. All right, there is the API specification, so in the mock, we need to add it. So I'll just do control dot implement missing methods, and it does it for me. I'm going to, just like the other methods do, I'm just going to forward it to the part that's shared between the front end and the back end of the mock. Shared.truncate index, which means that shared thing will have to have a truncate function right here. Okay, so how do we truncate? We would find, right, again with this thing, how that index corresponds to our base index, right? So, and then we would want to, ultimately we're telling our own log to truncate itself, right? Is there a truncate? There is a truncate. Right. So we're truncating to the length. So that'll be the index, the base, actually it's just that. It's just truncate to that. Actually, it's only if we can get something, right? Yeah, because we might not want to truncate, so... And what does truncate do if you pass it something that's greater than? No truncation occurs, that's perfect. So then we're always truncating, right? So then... This should just be saturated, right? Saturating sub. Like that. So we take the index that they gave us, subtract the base index, and that tells us how many actual entries that we have after the base, and we want to truncate to that many entries. So let's say the base is 0, and they tell us 3. So truncate 3. That would mean keep the first 3. Is that correct? So this means truncate will include that index. Is that... Am I off by 1? Am I thinking? I'm saying truncate to the match index. So that says include that one. So I think this is correct, because if you had like 5 log entries and you said truncate 3, you should keep 3 of them. 1, 2, and 3. Again, thinking in my mind that it's 1 based, and if you matched, let's say you matched up to the end of term 2, you would say truncate 4, right? So you'd want to keep the first 4 because it's 1 based. Yeah, okay. I have to think through it several times because I'm often off by 1. How much does the VSC IDE run these days? How much do I run it? It runs as long as I'm coding. Hey, there's stock signal. If you're talking about how much does it run in terms of time, it runs as long as I'm coding. If you're saying how much does it run in terms of dollars, it's 0. It's 0. It's free. VS Code. You can even get Visual Studio for free now if you get the Visual Studio Community Edition. I was actually able to do my last consulting job with Visual Studio Community. I didn't need to pay for anything for the tools, which is really great. In the past, you'd have to buy like Visual Studio Professional, and it would run like, I don't know, $700 or something. And it would only last a few years because then they come out with another edition. These days, they're actually getting really good at making the tools free. Also, the language I'm picking, Rust, all the tools are free because basically everything's either Apache or MIT license. Yeah, you might have checked when, like years back, or they still have paid versions. What they do is they put extra features not everyone needs. So if you look at the feature comparison, wait, let's do that. Let's say I'm misspelling it. Visual Studio feature comparison or edition comparison. There we go. So this one's free, and what are you missing? Enterprise. Who knows what that means? I usually think of enterprise as like a whole bunch of stuff you don't really need. So I've never used any of these. Live dependency validation, architectural layer diagrams, architectural validation, code clone. I've never used that. But if you needed one of those, you need to pay for the enterprise edition. But yeah, see, all like refactoring, everyone does refactoring, right? One-click deployment's kind of neat. It's free. What about in terms of debugging? Okay, so code metrics, static code analysis, graphics debugging, performance, that's all free. If you wanted to do IntelliTrace, like, I don't even know exactly what that is. Memory analysis on .NET, snapshot debugger, time travel debugging. So those are like really advanced kind of niche features. Then you have to pay for Enterprise Edition. You can see there's actually a lot of similarity between the free stuff now and what used to be the minimum to get some of the tools you needed. They made more and more stuff for free. At this point, I'm like, why would I ever buy Professional? Because it is exactly what's in the Community Edition. My throat is really dry now. I gotta drink something. It's true that Visual Studio Community is not equal to VS Code. Visual Studio Community, though, you might need that if you have certain things that aren't in VS Code yet, like I needed to integrate with the driver kit. What else? Code signing. Like, I just wouldn't know how to do that. Maybe you can do it in VS Code, but I don't know. So, but anyway, you can still get the community one for free, and it has pretty much all the features that Professional has now these days. See, we haven't seen a bullet yet that is in Professional, but not Community. So I'm like, why would you ever buy Professional anymore? So there are lots of cases for, okay, so there's something about CodeLens that is partially not there but that's the only thing. So the only thing again, I keep saying this over and over again, but you might want to buy Enterprise if there's some niche feature that you like that isn't in the, oh, there was something about Xamarin there. Okay, so maybe you want Xamarin Profiler. I don't know. You'd have to buy Enterprise. Maybe it does, but then who uses Visual Studio collaboration tools anymore? You know? A lot of people I know use web-based stuff for that, so that you don't need Visual Studio anymore for that. Like GitHub. Guess they sort of, because Python and other languages are picking up. I'm thinking code clone is like git repo add-in. Yeah, but then why, like, you could just use git on the command. Yeah, I don't know. I think that the case for paying for an IDE is eroding over time as the free tools have a larger and more rich feature set. I guess you could say in that case, free software is winning over paid software. Yeah, so, yeah, I think I'm saying too many words. Let's move on. I had this bad habit of just like repeating myself and over-explaining, and I think it's because if I'm talking to chat and I'm not seeing anything come back on chat, I'm not sure if I should keep talking or not. Okay, so should I just test this? Because truncate should do what I want. Oh, wait a minute. We can't just truncate the log. We have to reset the last index and term, right? Yeah. So then, hold on. After we truncate the log, we need to say if it's empty now, is empty, then self.last term is self.base term. Self.last index is self.base index. Otherwise, we got to look it up, right? So, let last log entry equals self.entries index self entries length -1. There's probably a better way to do this, but we should be borrowing at this point, right? Borrow. Right, then we can say the last term and index come from there. Actually, the last index is this one, plus the base. Yeah. Well, I can keep them in the same order, I guess. This looks better to my eye if I do that. Semicolon. Doesn't Rust have a last? I think it does for iterators, but does it have it for vectors? Oh, I guess it does. It's an option, though. Oh, wait. Thank you, Radon 90. I can get rid of my if-else, then. Let me give you a point. Because I can just say, if let some last log entry equal that, then else that. Right? Hold on. What happened here? This got hosed somehow. That should go there. Wait a minute. What? No, it's just last log entry term. I guess it was wrong before. Yeah, I wasn't using it. So that actually helped point out that I wasn't using it. So if there is a last entry, then its index is the base plus the length. Actually, hold on. I don't even need this to be inside the... That can just go there. And then this can move out then. Right? Without the semicolon, put the semicolon at the end. There we go. Perfect. What's wrong with this? Oh, we need to say it's mutable. Alrighty then. Testing time. Run the test. Unexpected match index was 1, it should be 2. What happened there? What did I do wrong? Oh, that's wrong now. Because we're truncating, but then we're... Wait a minute. Wait a minute. The only way we can get into this else is if it's the first one we're appending, right? Because after we've appended it, then the next time we go through, it'll always be matching, right? When we append one, it becomes the last, so the last will be the previous. So I think this is off, right? This should be... Do I even need that anymore? Because doesn't it start out with being the previous log minus 1? Oh, and I have another problem here. If the base is the same, match index should be set to the base. Cell dot log dot base index. Yeah. And no, I have to be conscious of that. Shoot. So I ought to move this one into here. Actually, it doesn't matter, right? In both cases, the match index equals. the new index, which is always going to be previous plus 1. So we'll get rid of that. And then we're always going to append 1, right? So then this should go out here, and this should be that if it's not equal to, truncate to the match index. Wait a minute. That's not right either. Yeah, this math is wrong, I think. This should just truncate to the previous. Right, go to the previous, and then append 1, and it becomes the previous plus 1. And then the previous advances, and the previous term becomes the new term. Okay. Then what should I do about initializing that, and how do I, and are these correct? I think this is right because every time we truncate, if we truncate and append, it's plus 1. If we truncate and not append, it's not plus 1. So that will, the match being assigned after truncate will looks better with that. Okay, then, I wonder if it actually do I need to initialize that to anything now? Maybe just to make that 0 for simplicity. So if there was nothing in the log, we didn't match anything, right? If there's something in the log, then we either have to see it in our history, in which case it'll be the base index, or if it's in our log already, then we will either truncate to the previous one, oh wait, this is wrong. Hold on. We only can proceed if we find a common point. So this is completely wrong. Shoot. We can only set that match if we find a match. So what I can do is say the match has to be non-zero, right? If match is 0, then we have no common history. Right? If we found the common base, that's fine. But if we didn't, then there's no way to proceed. We have to break. Otherwise, we can truncate to that match index. We can truncate to that index. Previous or match. Previous or match. We need to have a match. Match has to exist. Match will only exist if we got to there. So then maybe previous index is not even needed. I need it here, but after that I don't need it anymore because we should be following the match index. I think that's what I'm going to do then. So that goes, this is just plus equal 1. And we only use previous log index to compare the history. So this doesn't need to be mutable anymore. And what about previous log term, though? Aha. It's the new log term. A new log term is the next entry. Correct. Which we oh, that's redundant. This could just be that. All right. This is looking better. I'm feeling better about this. This makes sense that we would advance the match index if we append. And we're only appending if we actually have found a match. Wait. That means this if should be on the outside. We have to have found a match so far. Wow, why is this so hard for me? Okay, I think I know what's missing. There should be a positive case, and their match index equals well, that means I need to keep around previous log index. Hmm. Hey there, Cthulhu. I'm struggling with basic algorithms. How are you today? Did I not wave to radon 90? I guess not. And Cthulhu. And Lumi. Right, you had a comment in there about Visual Studio Community that I missed. Now I see it. I'm sorry I'm struggling. When I struggle with this code, it's probably not as interesting. Or maybe you find it entertaining in a schadenfreude kind of way. I don't know. Good to see me streaming so late. It is getting kind of late, isn't it? I have to start cooking dinner. Actually, I need to put something in the oven to start cooking so it'll be ready in an hour. So maybe I'll take a short break. Let me get this to work first, though. I need to figure this out, or otherwise it's going to haunt me. I think I'm 99% of the way there. Thank you for the follow. It's the fact that I have several variables chasing each other, right? Match index and previous log index are pretty much going to be chasing each other. What if I make them the same variable and I initialize it to that? Wouldn't that make more sense? I think we're going to be making ravioli lasagna pre-made at Costco. Just pop it in the oven and it's done in an hour. You mean the struggle is part of the process? That's true. A lot of the time, though, I'm happier when I can just translate my thought directly into code and then wrestle with the compiler a little bit in the borrow checker. Then once I'm done, it just works, and then I clean it up and it looks nice, and then that's the perfect. You'll be over at 6? Okay. No garlic bread, but I need to think about what vegetable to go with that, because we had Caesar salad yesterday. Can't have it 2 days in a row, can we? Actually, I'm the chef tonight, so I can do whatever I want. So it might be another salad. If not, I guess we have corn. All right. I think that these variables are redundant. What if I just make that match index and make it mutable and make this one match term for oh, I can't do that. This one's match. Actually, I can do that with an F2, right? Then it won't rename this one. Okay, and then this one goes there, and there. Right, then I don't need to do this one. It's back to the not equal, which is better. And then we always advance. We always append and advance, unless this case is true. Actually, this case would never be true. That case is never true. So it's back to this again. It's okay, it's just a little distracting. Should probably wrap this up soon anyway, right? Or at least go on a break. Let me go on a break and I'll be back in a few minutes. I have the little timer here ready anyway. Where are you, timer? There you are. Let me take like, I don't know, a 3-minute break? Yeah, that's fine. I'll be back in 3 minutes after a quick break. Be right back. All right, I'm back. I'm back. Let's revisit this. So optimistic assumption that we're going to match based on what... Right, so that's a good assumption. We're going to say assuming that we match their base for the append entries, we're going to look through and see, well, is it before... Is their base before... This should be base index, shouldn't it? No, if this is basically saying we should have the entry. If we should have the entry, then compare it. If our history has nothing in common, we're done. We can't proceed. We can't even truncate an entry. If it's the same base, then we're going to truncate, so that should be to 0, back to the base, right? Right, base index, exactly. Oh, so then I don't need to do that, do I? I don't need to do that. We just truncate to it. If it's the same, then we don't need to do anything. It will advance. No, it won't advance. So yeah, I really should move that out here again. Okay. This is actually cleaning up a lot now that I'm sorting things out. So if there is another entry to append, if the term we already know is matching, it's not the same as the last one in our log. Hold on. Wait. Oh, right. We don't know if it matches yet. The optimist, this is it should match. This is what we hope will match. If what we hope will be the term is not the actual last term, then we need to truncate. Is that the right thing to truncate to? I don't think that that's right, actually. Yeah, that's not right. I would be that -1, I think. And then we're going to add 1. Oh, shoot. And maybe this is right. This is looking at the last one. Yeah. And that's always safe to do because we're going to end up rewriting history. Okay, maybe this is correct then. Advance the match index each time, and the term, right, is the term from the one we were looking at that we just appended. Okay, let's try this one out. It's still wrong. It was match index 1. It should be 2. Just out of curiosity, did I break the other test too? No, that one still works. Where the log matches, it works. It's where the log doesn't match, it doesn't work. So the first thing it should compare is the existing log term 1 with the new one log term 2. So let's see where that goes here. So term index will be 0, and it'll be less than, so it will compare. It'll compare zeros, right? So it'll be equal. It'll be equal again. The new term will be... Oh, wait. This looks too far, doesn't it? This might be looking too... Oh no, we already said it's less. Right, so it is looking at... This is looking at the existing entry, so here's where it should fail, right? So it would be same... Wait, does that mean I have... This is wrong then, right? Oh, right. This is misleading, this name base only. I need to use a different word than base only. Same up to previous. Same up to previous is what I wanted to what I would like to call it. Then this would truncate to 0, which is what actually this is what it should do, right? Oh, but it doesn't depend. Oh. Yeah, we need to do that. That needs to be done over here. That's what was missing, I think. All right. Oh, I need to adjust my camera again. It got more dark or something. Light being such a tricky thing to get right. All right. Run this again. I hope I pass it this time. Yay, I passed. Make sure I, oh, what happened here? How did I get a shell? Oh, I did a split. Let's just close that one. Yeah. Run all my tests. Oh, I broke something. Which one's broke? Elected leader unanimously breaks? What? Okay, let me run it with test threads 1. What test are we on? We are on candidate append entries same term. Oh, this one. This one's breaking now. Okay, what's wrong with this one? So the left-hand side had a log entry, the right-hand side does not. Why not? Oh, I see. So it should have a log entry, but it doesn't. Oh, that might be it. Yeah, that's wrong. Okay, that's the problem. That should be a 0. I don't know why I had a 1 there. Yeah, okay, run. There we go, I fixed it. So the test was broken before, and we didn't know because we didn't have a check there. What, another test failed? Revert to follower on append entries new term is broken. Okay. Thank you for the follow. Yeah, I think because we have stricter checks now on append entries, we're running into this. So leader revert to follower. Let's find that one. Leader revert to this one. Unexpected match index was 1, should be 2. Okay, previous is 0. There's only 1 entry. Why does this say 2? That should be 1. I don't know why that was the 2 before. Oh, there are 2 commands in there. Wait, how does it get 2 commands in there? Wait, what? Oh, it should add its own and then add the other one. Okay, so that it should be a 2. Then what? Oh, this one should be a 1. Yes. And then this one should be a 1 also. So it's building off of entry 1 that we have on entry 2 with term 2. All right, that should fix it. Yes. Okay. All right. Glad I'm rerunning all my old tests to make sure they all pass. So we had some buggy values in the test that were never checked before. We never checked those before now. All right. Okay, quick break for less than a minute. I need to go check the oven again. So where's my timer? There it is. Putting it just on 1 minute. Start. Be right back really quick. I'm back. With a shortbread cookie, by the way. Because he had to eat something before dinner. Spoil my dinner and all that, you know? Set a good example for the kids. Okay, so back here, right? I had a bunch of to-dos. So we do that now, right? Yes. Although, I'm not checking all the corner cases here. I think I should check the corner cases. This corner case where we have nothing in common. We just tested that. We tested that earlier. Right. Wait a minute. Did we test this one? Hold on. Is this ever possible to happen? I don't think it's possible to ever hit that. Oh, wait, no, there was. It's if it exactly matches on the first run, but the term is wrong. That's what it was. So I don't have a test for that, and I don't have a test for this. So this one, let's... So how would the unit test look for that? Where the previous index is exactly the end, but the term doesn't match. Yeah, okay. Then that's a slight tweak to the last test we did, I think. Well, it's not exactly a tweak. It's just a variation on this thing. So, follower... Dog doesn't like intruders, even if they're walking on the sidewalk outside. Actually, I think this is the one we're testing, and this is the one that we're not. No. Other way around. Hold on, then, wait a minute. Maybe this is impossible. If we start at the end of our log, we will go into equal. Oh, but with the term not matching. Yeah, okay, so then I know the case. It's not this one, but the previous one, right? This one. Oh, wait a minute. No. Sorry. It is like the last one. Only we don't repeat the first entry. Oh, wait, no. This is not right. Okay, and this code is actually wrong. Okay, so then that's where the the index does match equal, but the term is wrong. Okay, so then let me think. I don't know why I'm having such a hard time thinking about this. So the log starts out with a 1, and then we would have previous index is 1, but say the term is 2 instead. And then we would try to append 2, 3, right? So in other words, that this ought to be a 2, but it's actually a 1. What should be done is, because we don't have the receiver should say, well, we don't have, this is the one we have, that's the base, and it doesn't match what you say, so it should reply that the match is this minus 1, so that we get to repeat this entry, right? Yeah. Okay, so then it doesn't matter how many entries you put in here. We could have it be empty, or just put 2 in there anyway. What we should get back is this should be empty, and the match index should be 0. That's what we should get. So this would be follower discards the log, basically. You have to discard, well, you don't have to discard the whole log. We can discard one entry. Maybe refine this. So we can put 2 entries in there. That's what I'll do. Put 2 entries in there. So append vec and then I have to turn that into an iterator, right? Into iterator? Yeah, no. I forget how I made this work. I had to box it or something, right? Box new that. Yeah. Okay, so we're gonna put 2 entries in there, 1, 2, just to make them look different. And then we'll say our previous index is 1, but the term is 3. Well, yeah, 3. And we're gonna put 3, 4 in there. Okay. And we're in term 4. So that term should match. So here the match index will go to, this would be, 2. But then this should go to 1. Because it'll look at index 2, which is, that's 1 and that's 2, right? Because we're subtracting 1 to get a 0 index. It'll compare that term 2 to this 3 and say they don't match. So what the server is trying to say is it should be term 1 and then term 3 and then term 4, right? No. It should be 1, 2, 3, 4. No, it should be 1, 3, 3, 4. 1 and then 3 and then 3, 4. Yeah. Should I write this down somewhere? Not sure exactly where to put the comment. I'll say this, well, leader says this should be 3, not 2. Right? That goes, this goes with that, because that index is this one. Yeah, it's fun, in quotation marks. Hey there, Aaron Raft, or Aaron Raft. I said Aaron Raft because I'm working on Raft, but your name is Aaron Raft. Okay, so when the problem here is that it's going to say the previous index to this one needs to have the term 3, which it doesn't. So since the client doesn't even match on the previous, it can't accept any of these entries, so it has to say back up to match 1. Right? Basically to say, go back 1. I wonder if I should make that 0 instead of 1. To say we don't even know where we match. And then let the server figure it out? Don't know. I don't know. This is the most optimistic. That's that the last entry that was wrong. That we need to redo it again. But maybe if the last entry doesn't match at all, we ought to just punt and say 0 here. That would be the easiest. What if we just say that? Let's say if the previous doesn't match anything we have, then we doubt our own log, and so we can't match anything. Yeah, that's what I'm gonna go with. So, what happened with the name? But did I not make the name custom? Yeah, so this is follower rejects append entries with mismatched base. Or mismatched previous term. So yeah, it's the term mismatches, and since the leader only tells us the term and not the contents of the command, we can't replace it, nor can we accept the other entries yet. We get some of the implementation detail, but you wrote an implementation in Go before? It's pretty tough but rewarding when it works. Yeah. Mine is I form as the base for the game I have. So this operates on AWS, and there are 3 instances of the game using Raft. So one is actually running the game, the other 2 are replicating the game state. So it's live right now and it works. We're in the hundreds of millions of log entries. It forms a new snapshot state every 10 minutes. And I'm trying to migrate this stuff to Rust. Why did it take me 3 times to say that? Trying to migrate it to Rust. It's in C++ right now. I don't like my C++ implementation, so I'm not just porting that. I am taking the taking my knowledge and kind of rewriting it in Rust. I just realized I didn't set the timer for the oven, so I need to like subtract what 5 minutes from what I would have put on it, and say like an hour and 5 minutes instead of 10. Yeah. All right. So I got to go in an hour because we're going to have dinner. Okay, so this test should fail because I had that wrong, right? It's going to give me the wrong index. Right, it's going to be 4. It shouldn't accept the entries at all. So let's fix that. It's this specific thing. If that happens, then our base is untrustworthy. So we would want to do match index is 0 break. I believe that's the right logic there. And no, it's not. We got a crash. What's the crash? Oh, it kept its log entries. Oh, okay. The truncate happened when it shouldn't. Yeah, the truncate shouldn't. We actually shouldn't truncate. Where did I do the truncate then? Oh, it was here. No, it shouldn't go in there. Wait. How did it get truncated then? It shouldn't have. Oh, it didn't. That's still, you're right. We don't want it to truncate, so it should have the original. So, I guess I gotta repeat this again. That vector goes here again. Yeah. Yeah, we won't toss our log. We'll just say it didn't match what we had. Okay, it's still wrong. I am so overconfident. Left should be right. Did I not get the numbers right there? Oh, persistent storage. We had it stored right, the test I updated the number in the test, right? It's now term 4 and not 2, so we should say 4 there. All right. So my tester is wrong. Now it's passing. Okay. Run all the tests. Make sure I didn't break anything else. They're all passing. Great. So in that case, that takes care of that corner case. There was another corner case, right? So we're testing that. We're testing that. We tested the truncate. We didn't test this yet, though. That's where the base has nothing in common, right? How good is the VS Code support in terms of being Rust ID? It's okay. The debugger has issues, though. I can actually demonstrate that here. If I run that last test in the debugger, you're going to see some weird things for some of the variables. See that match index and that huge number there? Even though it should be something, the problem is that we have two different variables called match index. There's one here, but there's also one out here, which isn't computed yet. The problem is the debugger isn't smart enough to see shadowed variables, so I think it just picks one at random, or it picks the first one. So it's telling us the number of this variable, which hasn't been decided yet, because that variable, its value is only decided when this entire if statement is done, right? It's either going to be 0, or it's going to be computed from as a side effect to all the stuff that we did in the else, right? So we can't actually debug the value of that at all. If I put my mouse over it, actually that's interesting. It does tell me it's 2, but it doesn't show up over here under local variables. Does it show up maybe on one of these other tabs? No. So that's weird. I didn't expect it to actually give me the value 2, but there you go. It's better than what I thought, which was that it would either give us this enormously large number, or that it might not pop up anything. So the other problem is that it's hard to look into collections. So if I go to like append entries, okay, that worked. So sometimes it works, but other times it doesn't. I think it was a hash map it had a trouble looking into, or hash set. So sometimes you can look into collections and other times you can't. But yeah, so the debugging tools have some ways to go. But other than that, it's pretty solid. I use Rust Analyzer. This one? No, this one. I use Rust Analyzer. There's also the Rust plugin. This Rust Analyzer has some pretty cool features, including what I was just using. The automatically added buttons here to run, test, or debug. Rust Analyzer adds that. Also, it does those pop-ups for the language server. You can also turn on inlay hints to see the types of things. I personally don't like the inlay hints because it confuses my eye into thinking there actually are characters here. So when I try to put that in the clipboard, I can't. It just skips over it. So that kind of is unsettling to me, so I usually turn it off. Yeah, the debugger is just old. The debugger I've been using, maybe there's a better one now, but I'm using Code LLDB. The problem with this is that it's based on just the virtual machine, right? It doesn't have any special intuition or knowledge about what the Rust compiler did. And it could be just lack of metadata added by the Rust compiler, but it also could be a lack of using the metadata the Rust compiler provides, or just that there is no connection between the two and that information is lost. But however you put it, there's a shortcoming in using this debugger with Rust with certain constructs like shadowed variables and more complicated collections. So yeah, but if you're doing simple stuff, debugging is just fine. You can set breakpoints. You can either through Rust Analyzer's buttons here, you can enter the debugger or just run the test. And the language server is really nice. I have this set up to run Rust formatter on save, so I could show you what I did there. Where was it? Oh, it just runs it by automatically. But yeah, if you need to tell it an extra argument when you run at Rust FMT, it's there. Is it edit on save a different option? Yeah, editor format on save. Like, it knows to go to Rust format for that through, I guess, the defaults through Rust Analyzer. So Rust Analyzer ends up being the formatting provider for VS Code when you're in a Rust file, so it just automatically all works. Yeah, pretty neat. It's good enough that I haven't needed to use a different IDE for everything so far with Rust. It's just sometimes the debugging becomes annoying, and what I'll end up doing is I'll slip down into printfs, which I've done elsewhere in this code. I'll end up doing that. And part of that's just because then I don't need to actually run the debugger. I can just run the program and just look through the log of what happened. A better way to do this probably would be for me to learn the log crate and do it more correctly. What's the word? idiomatically. We do more idiomatic logging in Rust. But the fundamental reason why I'm printing a lot of the time is because it's hard to actually see that in the debugger. So I'm like, I'll just print it out. I'll let the debug implementation, the debug trait implementation for these values format it for me, and not need the debugger to show it. All right, everything was working, right? Close that. If everything's working, then I'm going to go on to the next corner case to test. Yeah. Right, it was this one, right? So we're testing the truncation, which only happens here now. We're testing the rejection, which happens here. We're testing the append. We're not testing rejection because of mismatched base. Nothing in common. So let's do that. That's another variation on this with some of the numbers slightly different, right? So now we'll say that, let's just say it's exactly the same test, only we've incorporated the base directly. So that's in here, right? Base term is 2, base index is 2. And there's nothing, we don't need to append anything to the log. But then they come back and they say, well, the previous is index 2, same index, but the term is different. Then we have nothing in common, right? So we should get the same result, which is a rejection with match index 0. And then this should continue to be empty, right? But then this should be a 2 and a 2. Because the server hasn't corrected us yet, but we will update our current term to 4. So follow rejects append entries with mismatch, with not mismatched term, but no common base. Run that. All right, yeah, I was pretty confident that would just work. So we don't need to mutate the log anymore. Cool. I think I've tested every condition through here. It actually kind of tempts me to find a tool to do code coverage, because now if we run all of our tests, we should cover every single line, except for that one. I haven't done that one yet. Should I add a test for that? This would mean like, oh wait, there is a bug here, because we're going to use the wrong match index. This needs to do, okay, there's a bug here. It should be match index 0, and it's not. It's just breaking. So let me make a test for that. This is where that we're just so far behind we don't even have the entry at all. So we could just make this 0, 0, right? And now it starts out at greater, so it should just so this should. I should use different wording here. We should say mismatched base. And this should be with what? No common base? Yeah, I guess that's fine. All right, run that. This should fail, right? Because the match index will be wrong. Yep, match index is wrong. Is 2 should be 0. So that should be fixed just by me doing match index 0 and then a break. We don't have the entry before this one. Oh, nope, something else. Panicked at assertion here. Base, oh right, the base term changed. Shoot. The base is not 2 anymore, it's 0, 0, right? Yeah. Cool. All right, and then run them all. I'm glad I checked that, because that was a bug. If I had code coverage, I would have seen that that line wasn't even covered, right? So now we're covering that, we're covering that and that. We're covering that and that. What about this line? I think we're covering that already too, right? I think so. Anyway, if the history matches... Oh, wait, there's a problem here, isn't there? We didn't advance one. Oh, no, we do advance one. Yeah. We're only doing a side effect here if we need to truncate and replace. So interesting. So the only time we ever call truncate is right before an append, so we could combine those two, right? If I provided an index with append 1, and then it could just auto-truncate if the index is greater. Or if the index is less than the last one we have, we could do the truncate at that point. Or I'll just keep it the way it is. 2 different calls. Anyway, I find this a lot more readable than it was a few hours ago. And it's pretty much complete. And do we need these comments anymore? I could improve this by making a wrapper around the compare that actually gives better names than less, equal, and greater. Names that reflect these comments, right? Let's do that. So I'll invent another enum based on those names. What to call it? Should already have this entry. How about entry disposition? Log entry disposition? I don't know about that. What does the word disposition actually mean? Define disposition. Intent, the way it's placed or arranged. Now I can't see it because of dark mode messing me up. Power to deal with something as one pleases. I mean, the second definition is kind of right. Yeah, naming things is hard. I'm gonna just go with that until I find a better one. And then here's the code for that, right? Function, like determine log entry disposition. That's a horrible name, but maybe we'll fix the name later. So I'll need a match index too, right? Well, index usize. And this has ordering less is log entry well, let's define these. Actually, it would help if I copied this up here first and just gutted it, because we only really care about renaming these arms, right? So we're gonna produce another value, which I'm gonna do in another match. This match is only just to give them nice names. Should already have this. Okay, so a short version of we should already have this entry. Log entry disposition. In possession. Possessed. And then that's how you spell possessed, right? I can't even spell today. Define possessed. Yeah, okay. In possession. It said evil spirit, but that's okay. That qualifies as well. Do not have, so next, and this is future, right? I guess we could say past, next, and future. Well, that really would be current, right? So maybe not past, but possessed, next. I don't like these names. How about contained? Possessed? That's the best I can come up with. I'm really just giving them better names. If I come up with even better names later, then I can put these names in there. So this is, what's wrong with this? Oh, that should just be index. And this is because this type needs to go away out of this implementation block. And up here with the other enums. And this is future. Mismatched types. Oh, I need to return log entry disposition. There we go. So then the intent is to replace the comments with these words. So if these words aren't good enough, I'll change the words. But really it's just a wrapper for the word so that I can say match self dot determine log entry disposition of this right here, match index. And then I can replace these with history, oh no, log entry disposition possessed. We should have this entry. Log entry disposition next, then it is the next one to append. Really the goal here is to get rid of all comments so that the names by themselves are enough to explain what's going on. So that I can read this 6 months from now and kind of figure out what's going on. So I would read this saying, okay, we're looking at the new log entries to append. We're making a copy of the term number for later, and then we're saying determine the log entry's disposition, so the log entry of that index. If we possess it, maybe it's we possess it, or something like that. Possessed, then we're just comparing the history to see if it's the same. If it's the next one, then make sure that the term is right on the last one, and append it. If it's a future one, then we can't add it because we don't have the next one yet. We have to have the entire sequence. We don't allow holes. All right, I like that. Make sure I didn't break anything. So, in other words, the fact that we have two matches now, this benefits humans to map the meanings of that to the comparisons of those two. You've read Clean Code before? I don't remember ever reading it, but I know about the book, and I've watched lectures from Uncle Bob. So I try to follow the ideal that the syntax and the formatting and the names we pick are for the humans, not the machines. The computer doesn't care if I give these fancy names or not. It really just cares to what it translates into machine code, and then it just blindly runs it, and it's comparing numbers. It doesn't care about intent. I want to look back at this code 6 months from now and be able to understand what it is without having to translate it back into English. Have that hard translation. I'd rather write this in English, but we're getting as close as we can within the constraints of the language we pick, right? All right, then we're done with this part. Do I want to do more outside of this? We've handled all of the oh no, there's this one. We need to advance the commit index to the minimum of the leader's commit and our own last log index. I can kind of build that into existing tests, right? How do we know what the commit index is, though? Oh, I know how I was going to do that. I was going to have a special server event for that. Yeah, so let's invent that. In server, in event, let's add, was I going to put it here or in the log, actually? I think we should have it here, and then the owner of the server will have provided the log. They can decide what to do about it. Yeah, so let's, I think that makes more sense. This would be log committed. And do I want to give a name to the argument? No, I think it's, I'll understand what that is. That's the commit index. All right, so that's going to break a few things where we switch on that, right? Maybe? Yes, missing arm here. Right. So what do we do when we're awaiting a vote? Yeah, we shouldn't. So this would be unexpected, right? Server event log committed would lead to panic. Unexpectedly committed log entries. I have a feeling like we're going to need that in a few places. So, like, we shouldn't be committing log entries during an election. So that's unexpected. What about here? Await message. I'm going to say no. Just like unexpected state transition. And you can tell I don't even care about the index. It should just never happen. If it happens, I just want to know. Await append entries. Okay, here we might want to know it. So I'm going to pass on that one for a second. Await entries response. We shouldn't... Oh, no, that is where we expect it, right? Actually, in both places, we'll have to deal with it. This is where the follower might advance the commit index. The other one is where the leader will. Okay, let's put it in place. And we're not going to panic, though. It's going to be commit index. And we need to... I guess we'll require it in that. So let's put that in here. Oh, we have it. Leader commit. There we go. We even have it here. I just never used it. Interesting. Oh, it's used for the append entries. Okay, so it's actually a different field then. Where am I? Where did I go? Here, right? This is what we match in the append entries. But then how we decide to move it forward is a different thing. So that would go where? Where would that go? Oh, yeah. I know. These are what we expect. So this would be follower commit then. Yeah, it would be follower commit. Okay. New variable follower commit. Right here, right? So we need to assert, I think, equal args.follower commit index. If they're not equal, we're going to say what? How do I word this in other places? Like something like that. Wrong follower commit. It's not in append entries. How about wrong index in wrong log index committed? Was blank should be blank. Was this should be the other one. Let me flip them so that it looks sane. There. Okay, cool. You know what I think I also want to do is we want to verify we actually got that message, right? This stops when it gets the message, the reply message, right? No. Did I get this backwards? Oh, shoot, I got this backwards. This is this is when we're awaiting it to be sent out. Okay, then this is wrong then. This won't happen here. Shoot. Then it's unexpected. This actually goes in the other place. This goes down here. Right here. So it goes with this structure, not the other one. This follower commit goes... Oh, I can just call it commit index. Yeah. But then sometimes it won't advance, right? So let's make this an option so that if it's something, we expect it. If it's nothing, then we don't expect it. That's how I'm going to handle it. I have spoken. Thinking about the Mandalorian. Okay, so log commit, right? Thank you for that follow. I appreciate it. I'm only going to be here another 35 minutes or so because I got dinner in the oven. But until then, I'm just going to be working. If you guys have any questions, let me know. Otherwise, I'm going to keep working. Okay, so this was commit index, right? But only if it is something. So we're going to say if let some commit, well, expected commit index equal that, args in front, then we're going to verify it. And we also want to write down that we saw it, right? Let Vute log committed, right? Because it might not happen. So that replaces these two. Else it's unexpected, so I'm going to copy what I wrote elsewhere for that. This one. This can be rewritten a little bit differently, right? It should be this dot map or dot and then something tells me I should do a map or no. Is it just and? Okay, when I can't remember this, I have a little cheat sheet that Musin told me about. This one. Oh, it should just be expect or something like that, right? Because I want to tee out and want it to panic if not, right? So, but expect takes a pre-computed slice, and I don't want that, right? What was it that you do instead of expect? I guess we could do it on wrap or panic. That's an expect. Expect is unwrap or panic, but I want to lazy evaluate it. Oh, what was it then? Yeah, the last time I didn't expect format, it told me that that was bad. I guess I can do it and let it tell me what the right way to do it is again. Just do that. Wait a minute. No. Hold on, I don't need to do a format because if it's false, then it's this. But if it's true, then I want to do an unwrap, right? What am I thinking of? Oh, no, then I get the expected commit index. Yeah, so it's just a let. Whoa. That I didn't expect to do. I want that with, and then the assert. And it's not going to complain because that is a constant. So that's what I want, right? If we get a log committed, then we better expected one. Otherwise, it's unexpectedly committed. And then we get the expectation and we check it. All right, so then I'm out here and just say if args dot commit index is some and not, oh, I never set that flag, right? This one log committed. And not log committed. Then, oh, I can do it the other way, right? I can say if it is some, then assert that log is committed. Otherwise, server did not commit the log. Yeah, I like that. Okay. Good, good, good. Where else do I need to modify things? Here. Okay, so all the tests we've done so far, we don't expect the log to be advanced, right? Dry throat makes me cough. We don't expect the log to be committed here, so that means that the value for commit index will be none. So all the places we didn't expect it before have to have a none. And I'm going to change, once I have these in place, I'm going to change a few of these to not have to make another test. We'll just leverage an existing test because it's easy to do, right? Oops. Commit index none. Lost my clipboard there. A few more. I didn't realize I made so many tests. If you would have asked me how many unit tests do I have here, I would have guessed like 5. Instead I have like 10. Alright, problems. Okay, I know about this because we haven't... That's probably going to be tomorrow's work. Okay, no other problems. So now I need to modify some of those tests to expect the commit index to change. So let's pick one. Receive a... I guess we could do it with this one, right? Do I have the white paper still? I want to make sure I understand this correctly still. We advance our commit on certain condition, right? Yes, if leader commit is greater than commit index, set the commit index to be the minimum of the leader commit and the last new entry. So I'm already checking the false of that. So let's test the true. So on some tests, I'll have the leader commit be greater than 0. But then I'll need to have one where it's leader commit and other ones where it's the last index. So I guess in some of them I'll have the leader commit to be a high number and make sure we do that. And other ones I'll do where it's a low number. Well, wait a minute. Yeah, basically, it'll either be... Wait a minute, why do they have a minimum to be the index of the last new entry? That's weird. Why couldn't it be greater? Why couldn't later commit be greater? Oh, it could be, but it couldn't be less. Could it? Oh, if it's less, then we wouldn't have even seen it. No. There are 3 variables here: leader commit, commit index, and index of last new entry. So what's the case where leader commits greater than commit index, but less than index of last new entry? What is that condition? That means we passed a bunch of extra entries, but we only committed to some of them? And the other case is where we've committed to more than we've said. Yeah, okay, so then there are 3 conditions, and we're already testing one of them. So the other 2, I need to basically have either the leader commit or the last new entry be one greater than the other. So I might as well just build it into these tests. Why make more tests when I can just build it in? So this one, receive append entries. We started with nothing. Let's do where the leader commit is like 10, but there's only one entry. So the commit should be bumped to 1, right? Because it's that the highest new entry is index 1. So this should get a sum 1. Someone. Okay. And then the other way around, where when we append a bunch, how about we just append one but we only. Okay, this doesn't have any other. I can't use that test. I need to have one where there's some other. There's more than one entry, basically. Or we append 2 of them. How about one of these ladder tests here, where we accept it? This is it's rejected. Rejected. Actually, even if it's rejected, we should advance the commit index, right? Yeah, let's, we can do that, right? Yeah, it doesn't say anything about it being accepted or rejected. We can advance the commit index before, oh wait, new entry. So it has to, we have to have accepted the new entry, right? All right, so I can't use the rejected ones because it doesn't make any sense. I need to use an accepted one. How about this one where we rewrote the log? Yeah, replaces mismatched entries. There we go. We had one entry. They replaced the first one and added a second one. And let's say we advance the commit, the leader commit, but only to index 1. Now, even though we have 2, the last index is 2, this should go to sum 1 again. Right? So this first case, we tried to advance it to 10, but it should be minimum to 1. The other one was where we set it to 1, even though it could have been higher, and it'll be 1. So that, and the other cases all are none, so that'll cover all 3 possibilities. So then, I expect these tests to break. So let's run this one, it should break. Failed because of server did not commit the log. All right, that's what I expected to see. My head was covering it, but you get the idea. So we need to handle that leader commit. So that's back in mobilization, back in this process append entries, right? Okay, we did that. It's not a to-do anymore. I think we do that after we get all the way out, right? Yeah, right before we send the entry, because this one stops, that causes us to stop waiting. So we want to do it here, right? I think we just take the logic directly from the thing in here. If leader commit, which is if append entries dot leader commit is greater than our commit index. So that's self. Where do we? Oh, I never actually store that yet, right? So let's add a self commit index. Then set the commit index. So self dot commit index is. I take the minimum in Rust. I have some surprising gaps in my knowledge. Oh, it's comp min. Okay, standard comp min of these two again, right? Let's keep it true to the white paper. So they put leader commit first, and then they put this. It's possible it doesn't advance at all, right? So let's say let commit new commit index equal that, and then if new commit index is greater than self commit index, then we want to actually save it and tell the user that we saved it. So the telling is this part down here. send event log committed. New commit index. Alright, so then I just need this commit index in self. So self, I can't control click on what else is nearby. Persistent storage. Okay, here we go. Right here, commit index, usize. So that's always going to be initialized to 0. So where we initialize mobilization, it'll be 0. Commit index 0. Alright, let's try it. Oh, there's a warning. I was about to try it out, but there's a warning. No parentheses needed. Alright. Try it out. It failed. Server did not still didn't commit the log. Gosh darn it. Alright, what are we doing wrong? Leader commit 1. That should be greater than 0. We're waiting for the answer, and while we're waiting for that, we should get a commit, right? We should get this event here. And I set that to true. Oh, so that'll be true. Okay, so it was false, so it never got a log committed. But it should, right? Shouldn't it get to here? Let's put a print message so I can actually see if that's happening or not. It should go here, right? Committing log through index blah. New commit index. Run this test again. So here's the append entries, and here's the response. It didn't send the other event, did it? Okay. Oh no, that's a message. We don't know if it sent the event. No, it didn't print anything, so it didn't. Why not? Do I need another print to see why? We should get to this one, right? Leader commit is something. Our commit is something else. That and that. Run that. Yeah, it's greater than, so why didn't it do anything? Oh, that's the wrong variable. That should be index of last new entry. So that's, yeah, I had the variable wrong. That's self.log.lastIndex right here. Self.log.lastIndex. Run that again. Okay, it passed. So I should see that print message in there too. Committing log through index 1. Great. So I don't need this one anymore, I don't think. I still would like to keep that in there, because that'll be useful later. Did I just run them all? Including the other test? It should all work now, right? Great. So we're done with one half of log replication, right? We're done with the follower half of it. That last to-do is done. Yay, we're done. So the other half is the follower side, which is that when we get a response back, we have all these things we have to do, right? Update the term and revert to follower if the term we receive back is newer. Return earlier for not the leader. Update our match index for the peer, clamping it to our last index if they gave us a bad number. Update our commit index if a majority of peers have replicated entries. And then send another append entries if we have more long entries for them. But I don't have time to do that now. This is probably a good stopping point because we're done with one half of it and then we have the other half to do next time. So I'm just gonna Actually, before I commit, should look to see if, just glance through the code and see if there's anything I can easily refactor out of this. It is kind of complicated here, right? I kind of feel like the computation of the match index could be done somewhere else. And then the advancing of the leader commit can be done somewhere else. Match index is used outside for the result, right? Hmm. Okay, so basically this whole else clause I should extract out as another function, right? Because it's handling the update or accept decisions. Okay, I think I'm going to rename this actually. This should be accept and update. Specifically, it's update the term, right? Yes. Accept and update term instead of update. So then this whole arm is accept append entries. So let's call it that. Accept append entries. Mutable self, I don't know what else I need, but we're going to end up returning a match index. Right? Always we return a match index, so there's no early out of here. Okay, so then this would be accept a self, accept append entries. And then this all moves up to here. Paste. Now what variables do we need? We need the event sender, we need the append entries. Okay, so we need these two. Dry throat. Talking for 4 hours while coding, you get a dry throat. This is why you should always recommend and remind streamers to hydrate often when they're talking a lot. What other variables do I need? I don't need anything else. Great. So it's just append entries event sender. Append entries event sender. Okay, but then it is moved if I do that, so let's have it be borrowed instead. So you can borrow that. You can't... Okay, so then I need to borrow that. Oh, shoot. I really do want to move parts of it in. Okay, so then go back up. I do want it to own most of that, but I want to keep around the leader commit. So let's fetch that first, I guess, right? Or can I do the leader commit stuff first? That'd be easier, right? Do the leader commit first, then figure out how to append stuff. Oh wait, no, we can't do that because that might change. Okay, so let's get the leader commit first. Extract it out of append entries so that we can then let accept append entries consume it. So then that goes there. Cool. And we're all happy now, right? I've extracted that function. And then I could even extract a function here, right? This would be like self dot commit log to leader commit, right? Function commit log mutable self leader commit usize returns nothing and does that. Okay, I need the event sender. Fair enough. All right. Event sender. Cool. So now it fits on one page, which is perfect. So we first decide what to do about the request. This was meant to be generic, right? It can handle any kind of request, not just append entries, because we're just looking at the term. Yeah. And it's actually from the perspective of... Oh, actually, no, it's not a perspective. I don't like that name, though, decide request. It's like the long form of this would be decide what to do about the request. Decide what to do about the request. So what's a short version of that? Decide request verdict or something? Verdict? Yeah, let's do that. So then F2 that verdict. Request broker? No, what we're doing is we're deciding upon the verdict for the request, like what to do about the request. The long form would be decide what to do about the request. And the only thing about the request that we need to know is the term number. But that name is too long, so I'm calling it decide request verdict. So it decides what to do. The decision can be either reject it, accept it, or accept it and update the term. If it's accept and update term, we update our term. Then we get the leader commit. Now, if we decided to reject it, the match index is 0. If we decide to accept and append entries, or if we decide to, if we didn't reject it, then we either accept it or accept it and update the term. Either way, we're going to accept append entries. Then, if the leader commit is newer, we're going to commit the log. Then we're going to respond with the results saying what we matched up to and what our term now is. And we're going to send that message. So that's pretty self-explanatory, right? Commit log is pretty easy. We just see what the new index is based off of the minimum of what they say and what we have. And if it's newer, then we commit it. So this is just an optimization so that if it didn't move, we don't send a message we didn't need to send. Okay, and then accept append entries. Actually, it sometimes doesn't accept them, right? Also, this line is in here. Shouldn't that be outside? If we decided to reject, does that mean we're not reverting? Yeah, because their term is less. Yeah, so if we accept to append entries, one thing we do is we become the follower, always. Then we are matching our log with theirs. For a log entry, if we possess it, we make sure that the history is either has nothing in common, and then we're rejecting it. So I'm going to rename this. It's not accept, it's try to accept, right? The only problem I have with try, though, is that idiomatic Rust, for try, you're supposed to return a result. So how about a different word here? I don't know. Consume? A synonym for try. Attempt? There we go. Attempt. So if it returns 0, then we rejected it anyway, right? But I didn't want to put the decision into here because that's unnecessary. This doesn't need to know about the decision. It just attempts to accept them. So it's possible it can reject it if the history has nothing in common. It's possible to reject it if the next entry has no its base is wrong. If the base for the next entry is wrong, then we can't accept it. If it's in the future, it has no base, we can't accept it. Otherwise, If it's the next entry, we append it. If the history was the same up to the previous, now we've found a discrepancy, and we're going to truncate the log immediately and add, basically rewrite, this rewrites history. This removes all history at the conflict and after, and then replaces it. So after we get out of that, the next one, it should go into here and just be appending from that point on, right? I think so. Because the next loop, it's going to, again, check the index with the last index, and if we had truncated it, we would have chopped the index down to what we're currently on. Okay, this makes sense to me, and I can read it back and understand it. Now the trick will be, 3 months from now, can I do the same? And then, yeah, so I went over everything then, right? All the new code, at least. All right, time to check it in. And get ready for dinner and all that stuff. Get cola. It's the caffeinated Git GUI. So progress in Rust implementation of progress in Rust implementation. So add log entry term and log truncate. That's that. Add event log committed. Should I explain what these mean? Why not, right? Add log entry term to ask the log to look up the term of a given log entry. Add log truncate to discard previously logged entries. Add event log committed to let the end user know, not the end user, but let the user, the Raft user, Raft host, let the host. I like to call a host. I like to make user like a human, and host be like the program or process or integrated framework in which the thing is being held and used. Let the host know that more entries from the log are now considered to be committed by the cluster. That's that change. All right. Let me skip that one for now. Mock log. So that goes along with adding the those. So we're just going to stage that. Okay, so this is modifying some unit tests and adding more, right? So essentially it's add tests and code to make the tests pass to ensure the server, when receiving log entries to append, behaves as specified by Raft. It does its thing. And this is the implementation of that. Oh, but I had some enums, had a commit index. Do I need to list that? Nah. I guess we could. We're not actually using that. We're just advancing it and then telling the user about it. We're going to use it later, right? Actually, we are using that. We're using that to know when to tell the host that it changed, because we compare with what it was before. I think the rest will just accept it all. Oops. Did that get unstaged there? Okay, so then how do I do a amend last commit there, or we do that? Commit that. Because that's what I meant to do. All right. Git push that. One more running of the unit test. Oh, what happened here? I'm being rated by CM Griffin. I'm just about to go eat dinner, Chris. I'm sorry. I'll explain what I'm doing as I'm wrapping up, though. I forgot to commit to put that into my commit, so I'll have to do another commit anyway. But just making sure all my tests still pass. We implemented replication of state, at least the follower end of it for Raft, which is sort of depicted in this diagram here. Okay, it's hard to see in dark because dark mode is all screwed up, but Raft is a consensus algorithm. I use it in my game. So I can show this other screen here with my game on it. I should not have closed it before. My game is inspired by Ultima 4 and 5, right? The server for the game, since it's multiplayer online, it's running in Amazon Web Services, and we have 3 program instances. They each have the same state of the game. One of them runs the game, it's called the leader, and the other ones are just copying the state. The reason for that is if the leader server program were to crash, or I decide to stop it so I can update the code, the game will still run because one of the other 2 servers will take over as leader, allowing me to then change and restart the server that was stopped, bring it back into the cluster. It's really neat. You get continuous uptime for your program as long as you have a majority of servers running. If 2 of these crash, we're kind of screwed. What will happen is you can still talk to the 3rd instance that's still up, but nothing can change because it can't get consensus being a minority. And the way that the algorithm works is there's 2 main parts to it, but it's kind of, the first part's kind of depicted in this kind of diagram. This is the election process. Actually, let me reload this to get it fresh. So at the very beginning of time, right, we have 5 servers that none of them are the leader. They each start a timer. The first one to expire, because they're all chosen random intervals, first one that expires will say, hey, I want to be a leader of this cluster. So it starts an election. It sends out vote requests to all the other servers. All the servers that see a vote request, whoa, that was my timer for the oven. All the servers that see a vote request, if it's the first one, they'll say, sure, I'll vote for you. And so it's about to be elected leader because it's going to get a unanimous vote. It becomes a leader. A leader of the cluster is allowed to change the state of the cluster by adding in state changes. It's kind of like version control commits, right? So in this moment in time, I've had 4 new changes, log entries, whatever you want to call them, differences to the cluster state created on the leader server. It starts to replicate them by sending them to the follower server. So you can see the followers are always slightly behind because they have to receive the message from the leader, and then the leader has to acknowledge back to them that a majority of the servers got it before they finalize it. So the ones that are kind of a dotted line mean they have the log entry, but they don't know if it's been committed by the cluster yet. They don't know if it's safe to assume that the majority of the cluster has the data. But eventually they not only get a copy of the data, but they get told by the leader that, yeah, okay, everyone has acknowledged that, and so now they're all up to date, right? The particular consensus algorithm safely suggests oven check takes priority. The requests are burning. That can go in a few more extra minutes. It's fine. So that was a really, really quick overview of the election process and the state replication. What I worked on today was, from a follower perspective, receiving these updates, storing them, and making sure we're in sync. So I had to handle all the corner cases. Tomorrow I have to do the flip side of that. So in my code, the function was called process append entries. It was this one. This is where I spent all my time today. So I got it to almost fit in one screen by refactoring a bunch of things out. So we first decide, what are we going to do about this request? If we accept and update our term, we update our term. This happens if we receive a request and it's a brand new leader, right? New term. Then we stash the leader commit because we have to decide whether or not it's been committed or not later. Now, if we reject the decision, then we're going to return a 0 for the index that we agree with. Otherwise, we're going to attempt to accept those entries, and we're going to get back the ones we agreed with, which we're going to put in the response message. We construct here and send here. And meanwhile, if the leader has said that the cluster has committed more entries and it's more than what we have, then we're going to say to our host that, yes, you can now commit up to the leader's commit log entries. So that's a really, really high overview of what I did today. Tomorrow I have to handle the response coming back. So this is from the leader's perspective, where this stuff I did today was from the follower's perspective. Leader's perspective is when we receive back results from unappend entries, we revert to a follower if they're in a new term, right? So if we're behind, if we were a leader but someone else has taken over, we have to become a follower. If we're not the leader, we need to ignore the message after. We only need to update the term, and that's it. If we're the leader and the term is current, then we're going to update our understanding of how far along the log that the peer matches our log. And then we're going to update the commit index if a majority of peers has replicated the entries. So the idea is you make sure at least 3 out of 5 or 5 out of 7, a majority of the servers have acknowledged that they've replicated the log, and only then do we say it's safe to assume that those entries are preserved. And that's called committed. And then if we have more log entries we've generated in the meantime, we're going to send them after that. So I'm going to work on that tomorrow. I have to run though because dinner's ready. If you like that, so what you see so far, please come back next time. I'm kind of sad that you guys just rated and I have to go rate somebody else, but we'll find someone good for you guys to watch. Let me look at my following list. I can't rate CM Griffin because he just rated me. Well, thank you, Captain Dusty. Yeah, and you can try out, if you're interested more in the game stuff I'm going to be doing, you can try it out right now. The game is live. Like I said, it's operating, but there's not much content here. There's mostly just test content. Random hallways, a few monsters in there. If you like that kind of game, it's very retro. It's from the early 90s. And we'll be adding more game content later, but right now I'm just in the process of changing my back end of the game from C++ to Rust, and then I need to equip the game engine with more stuff in there. Yeah, I am doing Advent of Code tonight. So how many hours is that from now? So in about 2 hours from now, I'm going to be streaming again, but it's going to be focused on Advent of Code. So I'll be back for that in a couple hours. How about we rate just Primogen? What's he working on right now? Oh, he's working on Advent of Code. Okay. Very, very fun streamer. The Primogen. If you haven't seen him, then you should check him out. We're going to go check him out right now. And let's see. Any parting words? Stay safe. Be well. I'll be back in a couple hours for Advent of Code. If I don't see you then tomorrow I'll be working on this stuff, some more of the Raft algorithm. In Rust again. So take care, everybody. Please enjoy the Primogen. Say hi. Bye.